Yeah.
On a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, and welcome back to the channel that suffocates stupidity with the plastic bag of science. It's the start of a week, and that's always a sucky time, so I try to brighten the start of your week with a Monday night debates, and we've got a good one tonight, because we have someone that has not been on the channel before, seems to have quite an interesting background. You may have seen him on MC Toon's channel, and possibly Mr. Sensible's channel. His name is Kyle Adams, and I'll let him introduce himself now. Kyle, welcome to the show. Hello. Oh, you're still muted, yes.
Yep, there we go. Hi.
There we go. Thank you. Yeah, thank you very much for joining. I do appreciate it. Why don't you just take a couple of minutes to introduce yourself and tell the people what you're about and where they can find you on YouTube?
Just look up my name on YouTube, Kyle Adams. You can also just search Flat Earth Kyle, and I'm there.
Okay.
You could also search the Flat Earth Institute of Science. I'm the professor over here at the Flat Earth Institute of Science.
Okay, could you tell us what the Flat Earth Institute of Science is?
Well, we're doing an online school kind of a thing here, and we're just presenting facts that support the Flat Earth and trying to put it in a systematic, organized fashion that you don't see anywhere else. Okay,
fair enough. I've had a look at your channel. There's quite a few interesting videos on there. So when I contacted you, you agreed that we would have a format of you would have 10 minutes of evidence to present. So why don't we just get into that? I'll let you have the floor uninterrupted for 10 minutes, and you can present whatever evidence you need to.
Okay. I've got a great video that I've put together. I just been all night working on it last night, and
okay.
I'm just going to premiere it right now, and I'll just share that with you.
Okay.
And it's a little over 10 minutes, but I'll just play it faster, and so
okay.
It'll go just fine. Let me know if there's any issues in hearing it or anything like that, all right?
Okay, we'll do.
Okay. Screen share. There we go. Share. Okay, and here we go. Hello, welcome to the Flat Earth Institute of Science. I am Professor Kyle Adams, and I must say, our public debate board has been a great success. It is continually growing, and a lot of great points are being made on both sides. It is most certainly not an echo chamber. In fact, there are currently more anti-flat earthers participating in it than there are flat earthers. With that being said, I would love to see more flat earthers come and be a part of it. There's a link to it in this video's description. Anyway, I would like to publicly recognize one of our participants, Night Sky Jeff. Even though he is very much a globe earther, he is a sharp guy and has pointed out something I didn't notice before concerning Rob Skiba's Setting Sun video. In his video, Rob Skiba highlights a news report where a professor from Notre Dame University used a magnifying glass to demonstrate how the atmosphere refracts light downward as it travels through the atmosphere.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see all of pretty much all of Chicago without the lower building, including what's at ground level.
So the atmosphere really is like acting like a lens.
Yes.
Rob Skiba then used his own lens to demonstrate how the sun can appear to set on a flat Earth due to atmospheric refraction. Now this is what Night Sky Jeff was able to point out to me that I didn't notice before. Here on the left, the professor from Notre Dame used half of a magnifying glass to perform his demonstration, while over here on the right, Rob Skiba used a full magnifying glass to perform his demonstration. This has caused me to go back and rethink things. Typical magnifying glasses use convex lenses, and this is how a convex lens works. The top half refracts light downward, and the bottom half refracts light upward. So in Rob Skiba's demonstration, he used both upward and downward refraction. Now, if a full magnifying glass is supposed to represent the atmosphere, then the atmosphere would have to be thin at high altitudes, dense in the middle, and then thin again near the ground. That is not what we observe in reality. That is why the Notre Dame professor only used the top half of his magnifying glass. But I'll point out here that there is something wrong with his demonstration as well. Magnifying glasses use a radial gradient, wherein they are thicker in the middle, and then they get thinner all the way around. The atmosphere doesn't get thinner when we look left or when we look right. The atmosphere has a vertical density gradient, not a radial one. So this most certainly calls for a new, more accurate experiment and demonstration, as good science demands. All right, so here is one experiment we can do. We can create a vertical density gradient in some water by pouring a bunch of sugar into it and letting it dissolve. Here we have a person shining a laser beam into the water, and we can observe that light getting refracted downward. Now, if we were to put a picture on the other end of the tank of the sun or a city, the question is, would that image appear higher or lower than it actually is? Now is the time to form your hypothesis. Please note how many people out there frequently claim that downward refraction should cause things to appear higher than they actually are. Here you can see this claim being made by timeanddate.com. Here, a YouTuber by the name of Mick West was able to perform this experiment for us. Now, Mick West is a globe earther, and please note how here he put a curved piece of metal in his fish tank to represent the curvature of the Earth. With that addition, what we are still going to look for is, does the city look higher or lower after the sugar is added to the water?
So first of all, I'm going to do it without sugar. Then I'm going to add sugar. Now, when you add sugar, what you do, you fill the tank with water, then you pour sugar into it later in the bottom. The sugar at the bottom starts to dissolve, and that makes the refractive index, the density, essentially the optical density of the water will be higher, lower down, and light bends towards a more dense medium, which is what normally happens in the atmosphere because the area is denser lower down. So you should see the light curve downwards, and we should, looking at this end, see more of Chicago from this end. So let's see what happens. So what do we see here? We see the same view of Toronto that we saw before. It is magnified, of course, but it's not distorted in any way. The image is exactly the same. It's just bigger because we're looking through the water.
Magnified? That's an interesting observation. That sounds like what Rob Skiba said.
So I've got about 6 gallons of water in here, and I'm going to add around about 5 pounds, I think, of sugar. One thing I didn't take into account was that it was very, very cold in my garage, so it took a really, really long time for the sugar to dissolve, and I ended up moving the fish tank inside. 5 pounds of sugar. So what I ended up doing was removing some of the water and just lowering this curve a little bit because it was a little bit too much for my needs. But what actually happened was it worked. The water dissolved the sugar and we get a bending laser beam. Now, it's most obvious if I kind of point this laser beam upwards a bit and then move the beam down, 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 and you'll see as you get to the bottom here, it bends over at the far right-hand side. And that means if we're looking up in this direction, if you have a camera here, which I'll put in there in a second, the line of sight from the camera will go up, over and down, which means it will go over this obstruction here. If you see, I send this light beam out, and it actually bends down right over the other side. It actually goes over this little lump of metal I have here, which I used to raise the obstruction because I flattened it a bit too much, and it comes over the other side. So what can we see at the other end? Well, at the other end of the tank, I have a picture of Toronto, not Chicago. And the interesting thing that happens is when I move the camera down So it would normally be obscured by this curve and this block here. Instead of being obscured, the distant image of Toronto actually seems to get compressed and rise up in the air. All the way down. And you can see it's being compressed. Up again, it's back to normal. Go down, it's compressed.
All right. So did the downward refraction cause the city to appear higher or lower than it actually was? The compression most certainly made it appear lower than it actually was. Sorry, time and date. You guys got it wrong. This supports the flat Earth. Now here in another video, Nick West is going to show us what happens when we remove the curved piece of metal and view the city across a flat plane.
So could refraction make a flat Earth look like it was actually round by making things appear to go below the horizon? Well, if you move the camera down, you can see that it kind of looked like things are going behind the horizon. But look at the laser spot that I put just right on the bottom of the skyline of Toronto there. If you go down, you'll see the laser does not disappear behind anything. In fact, it stays visible all the way down until we go off the bottom of the aquarium. You can actually see it still visible when we're right down to like a fraction of an inch above the ground here. And you can see the actual skyline of Toronto has been completely distorted there.
Wow. Now with enough distance, I'm certain we could get that entire skyline completely out of view.
But it's all actually still there, as you can tell, because that one laser spot is still getting through over this flat section of the tank. Now over the curved section with the obstruction, you get the same type of thing, except here we do actually get the light disappearing behind something, because there's actually a physical barrier here, an actual physical curve. If the ground was flat, there's never anything that's between you and the light. So there's always going to be some path to that light. So if you got a very bright light, and if you were on a flat plane, you would always be able to see a light. But on a curved surface, or a surface with obstructions, as long as it's good enough of a curve or enough of an obstruction, you will actually see the light being extinguished.
Now Mick West just said that he believed if the Earth was flat, the light from the laser should be able to go on forever, even though it would be getting bent downward by the atmosphere. I hope you see the error in that logic there.
It's between you and the light. So there's always going to be some path to that light. So if you get a very bright light, and if you were on a flat plane, you would always be able to see a light. But on a curved surface, or a surface with obstructions, as long as it's good enough of a curve or enough of an obstruction, you will actually see the light being extinguished.
Since the light is getting bent downward, it will eventually crash into the ground, and when it crashes into the ground, it will lose the ability to go on forever. Here, the crazy Russian hacker was performing the same laser sugar experiment, and you can see the light hitting the bottom of the fish tank before it reaches the other side. If the bottom of the fish tank were not so reflective, that light wouldn't bounce up and reach the other side, and a person over there would not be able to see the light at all. This is how night is able to happen on a flat Earth. And there you have it. Now, if anyone would like to join our public debate board, we've got a link in this video's description. It's totally free. So we hope to see you. Thank you for watching.
Okay, that was my latest video. Any questions? Did you hear it all right?
Yep. No, that was all fine. I just need to bring you back into the production. Bear with me a sec. I will show my evidence, and then we can discuss the things that you brought up.
Okay.
Just bear with me 1 second. Oh, sorry, my computer's freaked out. Very interesting. I've seen all the things before, and I've already got some counter arguments ready to go. So I'll do those when we go to the back and forth. Let me just bring you back into the production, and then we'll get this ready to go.
Seen all that before. I don't know where you got that from. I haven't
the arguments.
To make observations before.
I've heard all of those arguments before, and I know how to counter them. So, but we will get to that.
Okay, I look forward to hearing that, because I have not heard any counter arguments to those yet. But yeah, it's a brand new video, so what can I expect?
Right. So what I'm going to do is just give empirical evidence of things that we know. Okay, the fact is that Earth's been measured to have curvature, and Earth's been measured to have rotation. These are things that are testable, verifiable. Science should always be testable and verifiable, and all these things are. I can start with an entire list, which you've probably seen before, of radius of the Earth measurements, which is handily put together by our good friend MC Toon, mctoon.net/r. And there, I think there's 12 different measurements of the radius of the Earth by professional surveying teams throughout history. One of my favorites I like to talk about is the transcontinental triangulation of the American arc of the parallel, which measured the curvature across America. Interesting thing is that when you actually go and look at the details of all these different things, which again, mctoon.net/r, they all come to the same conclusion. All these teams that had never met from around the world, using known surveying methods, came to the same conclusion that the Earth's radius is what we're told. But you know, that's measurements. Not everyone has the ability to go and measure it. Not everyone has the knowledge that surveyors have or the equipment. So there's easier ways to measure the curvature. And you know, we can kind of do that with an experiment. So a good friend of mine, Sly Sparkane, in 2017 on the September equinox, he contacted a bunch of people around the world, I think 27 different people. And he got all these people to stick a stick in the ground and measure the angle that the stick made from the sun at solar noon. And 27 different people from all around the world. This video goes through all the details of all of them. And he did two things. He mapped the results onto a flat plane and onto a globe. Now, this is the results for a flat plane, okay? Now, the problem here is that it gives conflicting positions for where the sun should be. If the sun is small and local, then everywhere in the world when they're seeing it at solar noon should be able to pinpoint the same location. But most of them didn't get the same location, which is an issue. Why wouldn't it be correct on a flat plane? No matter where you kind of put those positions, depending on what map you follow, you never get a consistent position for where the sun should be. But what happens if you map it onto a globe? Right? That's the interesting thing, because if you map it onto a globe, the empirical evidence from all these people all around the world, what happens is that you get what we're told, that the sun is very far away and the sun rays would reach us parallel. Using this, you could even calculate the distance to the sun. I think they got within 1% of that calculation. And it's easily verifiable. You just have to contact some people around the world and have them do the experiment for you. And if you get conflicting information, then you have to go with the one that shows information that matches reality. And the only one that matched reality was when they mapped it onto a globe. So that's Sly Sparkane. But that's you know, a measurement. You know, people maybe could get the measurements wrong. So how about we do something even better? Another good friend of mine, Mr. Sensible, bought a weather balloon and sent it into space. Now, here is the money shot, as it were. This is at 35,000 feet. Okay, now there was two cameras on this, three cameras actually on this payload. One looked directly up at the balloon. Let me show you. So on the left, on the top, you've got a camera looking directly up at the balloon. To the right of that is the wide camera that's got a fisheye lens for the pretty views. And the camera that he used is a camera that doesn't have any fisheye distortions. Now, obviously, all lenses have some kind of barrel distortion, but when you know about how lenses work, you know that the barrel distortion wouldn't be in the center. So you can see that he's got these two reference points for what is straight, and you can see that they're both straight, and they stay straight throughout the entire flight. And like I say, if you get to, where was it, 37 minutes, oh, there he is. Yeah, you clearly see the curve of the Earth. Not only did this confirm that there's a curve to the Earth, it matched predictions of what the calculated curve should be.
It shows the...
So here he overlays the predicted curve. This is at 35,000 feet, and he overlays the predicted curve for 39,000 feet over the top of it. And as you can see, it's pretty close as to what is expected at roughly that altitude. But not only did it confirm that there's a curve, but if you look at the graphs on the bottom left, this confirms the air pressure density and the temperature changes that our model predicts. When this got to its maximum height, it was at 10 to the negative 2 torr, which is practically a vacuum, showing that no kind of barrier or anything is needed between the two. So what you can do if you're not sure by looking at that, you can take the image and compress it left to right, where you not only see the curve of the Earth, but also the curve of the atmosphere, which is also, again, what we expect. But that's not the only balloon flight that has shown these things. Everyone's aware of the famous dog cam. Now, dog cam, again, had two different cameras. It had a camera that had a fisheye lens for the lovely views, and it had a camera that didn't have any barrel distortions. And when you look at the two cameras, where it gets to the point here, the one on the left doesn't have any barrel distortion, the one on the right is the fisheye. And when you watch the one on the left, no matter how many times it crosses the center line, the actual horizon stays convex as we expect it to. It doesn't go concave, it doesn't, it's exactly what we expect it to show. And this is the one that doesn't have any fisheye. And again, on the right, they've compressed it left to right to show you an exaggerated version of the curve. Calculated horizon matches what it should be at that altitude, about 32.5 kilometers. So there's two things that get the same result, which is interesting. Not just up at high levels is it easy to see that the Earth is a curve. Another good friend of mine, called Miles Davis, who lives just down the road from me, took this. Well, this is a screenshot from a video he did, okay? He was standing at the top of a point called Terrapin Law in Scotland, just down the road from where I live in Fife. And there's a surveying plaque there, you can see it in the video, that shows that he's at 210 meters. So we know the camera height is 210 meters. The bridge pillars that you see that's got the red line on it are from the Forth Road Bridge. Now, the middle pillar is, according to the construction manual, exactly 210 meters above sea level. Exactly the same as the camera height. So we've got a tangent. We've got, a line of sight. We've got what your eye level is. Now, those hills in the background are about 40 kilometers north of Edinburgh. And the interesting thing about those hills in the background is that they are all at least 500 meters above sea level. Now, if the Earth was flat, and perspective works as flat earthers tend to say it does, then you would never see the mountains in the distance fall below that red line of 210 meters. They would shrink into it, but nothing about perspective or the way that anything works would make it shrink below that line. This, again, matches the predictions made by the globe, that those hills at those distances should appear at that distance below a 210 meter tangent eye line. So if he turned on the same video, he turned around and did a similar thing. This is looking in the opposite direction. On the left there is Hopetown Monument, which is again 210 meters above sea level. And this was an even better view because on the right there you've got one of the tallest mountains, Benemy, 1,011 meters above sea level. And again, falling below the 210 meter eye line, the tangent. That shouldn't happen. Nothing about perspective says that parallel lines intersect. That doesn't happen. So it would never go below that 210 meters if the Earth was flat. This matches what you would see on a globe. It's not just curvature that I can demonstrate though. It's the rotation of the Earth. Now, I'm going to do one quick video to show you the rotation of the Earth. If the Earth is rotating, as we say it is, then there's certain effects that we should get. One of the effects is the drift of a pendulum. Okay, now a lot of flat earthers have issues with Foucault's pendulum because they say it's driven by a magnet, you know, and stuff. Well, someone else that I know, the gentleman physicist, made his own homemade Foucault's pendulum, and it's in a block of flats. It's got no metal from magnetism and stuff in it. It's just a big bit of fishing wire with a big chunk of rock on the bottom swinging backwards and forwards. Now, he let this swing for, I think it was 43 minutes. And as you can see, it's swinging backwards and forwards, and it's dragging this little paintbrush through that ink pot. Now, he's at a certain latitude on Earth where if the Earth rotates as we say, and he's at that latitude, then there should be an expected drift. He let it swing for as long as it could, about 47 minutes. And then they measured the drift. Okay? They took the angle that they got, and then they measured that angle against the time that it took that they actually swang for. And they did some calculations and figured out what their latitude should be based purely on that drift. And it matched. They were, I think, about 1 degree off. That effect is because of the rotation of the Earth. That there is no reason for that drift to happen if the Earth is flat. Even more, there's no reason for that drift to match your latitude. If you're in the northern hemisphere, it will rotate one way. In your southern hemisphere, it's going to rotate another way. This is an effect that you can test for. If the Earth is rotating, there's something that should happen. Let's test for that effect. He tested for the effect. The effect was there. We've measured the Earth's rotation. We've measured the Earth's curve. It's empirical, undeniable evidence. And that's me.
Okay.
Right. I'll let you ask me any questions you want first, or do you want me to go through some of the things that you brought up?
I was thinking a lot about the part where you talked about like measuring the angle of the sun in the sky.
Yes,
on
there's
that.
Slice Arcane's video.
Now, with that, were all of the observers at the exact same elevation?
They were at whatever their elevation was. The elevation isn't the important thing.
Varying elevations?
Yeah, and you can map it all out onto the surface of the globe. But it's the angle that you get from it that's important. The angle that you get from the stick. Let me get one of the pictures up for you to see. I think it was 27 people that he got to do, and they all recorded it individually.
And even though they were at completely different elevations, they all ended up pointing in the same area?
Yeah, oh crap, I just went backwards. As we expect on Globe Earth, that's what we expect to happen, that the elevation wouldn't make a difference.
Yeah, that sounds like the Eratosthenes.
It is the Eratosthenes experiment, but with many more data points. Now,
yeah. But though it seems like it's falling for the same thing that he fell for, the big issue. And the big issue is that he didn't take the atmosphere into account. And so when there's no atmosphere, it just kind of falls apart there. It doesn't seem very sensible to me. If they're all pointing to the same thing, it's kind of like imagining the world without an atmosphere. But
at solar noon, the sun is directly overhead. It's going to be straight up there. So you're going to be looking through a minimal change in what the actual density is. You're not going to be looking through the curved atmosphere.
These are different places throughout the world.
Yeah.
Right. Okay. And so, it's at the exact same time, where it's
at the local points, the local point solar noon.
Okay. So if they're at different places at the same, and are they all at the same latitude here, or what?
Let me get the details up 1 sec. They're all at different points all over the world.
Okay, so yeah, exactly how they all are able to point to the same area, that only makes sense if there is no atmosphere on the Earth.
No, it really doesn't. It makes sense perfectly with the atmosphere. The angle that you get from the sun causing the shadow isn't going to be affected by refraction, because you're not close to, well, there is going to be refraction, but it's going to be minimal. You get the most refraction when you're looking through a curved portion of the atmosphere closer to the surface. That's where the lapse rate, the change in density over distance, is going to be the highest. Looking straight up into the sky, refraction isn't really an issue. Not so much that it's going to affect the details of this.
But the sun isn't directly overhead at every location on Earth. There's different...
that's the point of solar noon. You know, it's whatever the local solar noon is.
Yeah, and so whatever the local solar noon is. And so, okay, if it's solar noon in North America, it's going to be different. The sun is going to be at a different angle in the sky in North America than it will be down in South America.
And that is the point. You're getting a different angle, and you're measuring all those angles and mapping them out.
And if you don't take refraction into account, it's going to throw your numbers off really bad.
No,
so,
again,
it's like
refraction at that, when you're looking straight up into the sky, isn't an issue like that. It's not like when you're looking over the cold surface of a lake or something where the lapse rate is a lot higher. You know, refraction happens mostly when you're looking through a curved gradient. And that's not going to be happening when you're looking straight up into the sky.
Curved gradient?
Yes.
Okay, so we just looked at the whole fish tank experiment, right? With the
and
sugar.
he had the curved gradient in there.
That wasn't a curved gradient.
Of course it was. He had the curved surface. And then it would have... the curve
fish tank
would have...
had a curved surface?
Yeah, he put the curved surface in the bottom, like you said, to represent the curve of the Earth.
The curved surface wasn't affecting the refraction.
Of course it did. That's the entire point. The curved surface will make the gradient of density also curved above it. And that's what causes the refraction. It's the index between one medium's density and another that causes the refraction. And if that's curved, it's going to make it more. And that was Mick's point, is that when it's curved, you get the compression and everything as we expect on the globe. And you said it didn't raise up, but when you actually look at the bottoms of the buildings, the bottoms raised up and the tops squished down. It did compress it, but the bottoms definitely raised up, which is the point of bringing things above the horizon. But it's the curve that causes that refraction, because when he took away the curved surface, the laser and the background were just, you know, straight but a bit more magnified, and the laser was going straight. It's the actual curved gradient that causes the refractive effects.
You saw the part where he did it over a flat surface, right?
Yeah, and it was a straight line, like he said. You could, you know...
It wasn't a straight line. It was still refracted.
In
the
your
crazy
video,
Russian hacker guy, right? We saw that. We could see the line get refracted. There was no curved surface at the bottom of that tank. And that curve, it's still very
when he was pointing the laser straight on, you could see it hitting the city at the other side. It wasn't bending down because it was hitting the city at the other side. But the entire assumption of your video was that light bending down wouldn't raise up what you see. Where, of course it would, because that's the light that you're seeing. So if the light is bending down, you're going to be seeing what the light is bending to. That's how light works.
I understand that, and that's why we were missing a whole lot of the city. It was getting scrunched. We weren't able to see it all because we could not see all of the light.
Yeah, but it also...
You could only see a little bit.
It brought the bottoms back up a little bit. That's the point. It raises up what you see when you're looking... I mean, when light curves like that, you are going to be seeing what the light is curving to, which means that from your perspective, looking straight on, it's going to be raised up. That is just how light works.
The city did not look like it was getting higher. It looked like it was getting lower.
It compressed, but compressed, but the bottom raised up.
And the compression is what created the false sense of curvature. It made it seem like it was curved when it really wasn't. The fish tank, the bottom of that portion of the fish tank was flat, and then the crazy Russian hacker guy, that whole bottom of the fish tank was flat, and it did not affect the amount of curve. We saw it go across, and then we saw it hit down before it even reached the end of the fish tank. The bottom of the fish tank was not what was causing the refraction. It was the sugar in the water that was causing the refraction.
But it's the gradiated curved that caused the refraction. That is what causes refraction. Refraction's been quantified already. We know what causes refraction, and we know what refraction should look like. I've spoke personally with the world's leading expert on refraction, Dr. Adams. Not Dr. Adams, you're Kyle Adams. Dr. Oh, fucking forgot his name. I'll get you his details. He actually wrote a program of what refraction would look like on a flat Earth. But denying that that's how refraction works doesn't really change things, because like Mick showed, the bottoms of those buildings raised up slightly. The tops may have been compressed down, but the bottoms raised up, showing you more of what was over the curve.
The bottom didn't raise up. We lost sight of the bottom. That was the first thing we saw.
No,
when we saw the portion of the video,
the bottom's raised up. We
couldn't see the bottom at all.
The bottom, when he was looking down, you saw the bottoms and the tops squished together. It brought the bottom up as well as the top down.
Are you talking about when it got magnified, when he put the water in before the sugar happened?
No. When he was looking with the laser over the curved surface and it compressed, the top came down, but the bottoms also came up. You can see parts of the buildings that were higher up than they were before.
Do a screen share and we could go back and take a look.
I'm trying to get some footage. I'm trying to find the right video to show you the effects of refraction in real time. If anyone else knows the link to the video I'm trying to find of the guy who pours the gas on top of the tank with the tin behind it with the colors, if anyone can link me that video, because it shows what we need to see here very well.
Yeah.
So
you're trying to tell me that you can see the bottoms of this, like way down here? Like, can you see this, or did I not turn to the screen share on?
You haven't screen shared yet. Oh, it's going to knock that off again.
Okay. There we go. Screen share. And where'd the video go? There we go. You're telling me you can see the bottom of that?
One sec. Let me bring that up.
This is on the flat portion. Oh, no, actually, this one's on the other part. 1 second. Okay, here's the flat portion. I don't see the bottom of that.
That's the flat portion, and the laser is hitting the buildings.
The laser is hitting the buildings.
Yeah.
The laser's on the other side. He's kind of shining the laser through the...
Yeah, he's shining the laser from where the camera is looking, and it's hitting the buildings at the other side. I mean, it's quite blurred, but the whole buildings seem to be there.
The whole buildings seem to be there. I don't see them.
It's quite blurred. Is there a better screenshot with more clarity? Oh, I'm not showing it to people.
I don't know. That's kind of how it is. I can replay this portion of that.
Indeed. Right. You guys got it wrong.
The one on the right.
This supports the flat Earth.
Okay, this is...
Now here in another video, Nick West is going to show us what happens when we remove the curved piece of metal and view the city across a flat plane.
So could refraction make a flat Earth look like it was actually round by making things appear to go below the horizon? Well, if you move the camera down, you can see that it kind of looked like things are going behind the horizon. But look at the laser spot that I put just right on the bottom of the skyline of Toronto there.
The laser, that's the point.
You'll see the laser does not disappear behind anything.
The laser is on the bottom of the building, and you can still see the laser.
Sorry.
The laser is on the bottom of the building, and you can still see the entire laser, which means that you can see the bottom of the buildings. That was the entire point of what he put there.
Okay. Yes, I agree that the laser was still seen. We could still see the laser, even though, but the whole point is it's an illusion. Okay, it's an illusion. Okay, it looks like we're missing the bottom half, but it's really just getting compressed.
But we're not. That's the point is that you could see the bottom of it. You could see it because the laser was there. So you could still see the bottoms. Even if it was compressed, you could still see the bottoms of the buildings.
Just a very compressed version of it, maybe.
Yeah, but you could still, if you can see the laser which was on the bottom of the building, you can see the bottom of the building.
The laser represents the bottom of the building, is what you're trying to say. And so
that's Mick's entire point, is that he says the laser is on the bottom of the building. You know, that's where he's fixed it, right? And he doesn't change the position of the laser, he just changes the position of the camera, and at no point does the laser go out of view, showing that we can still see the bottom of the building.
Yeah, and, okay, his laser beam was reaching all the way across. I have no clue if his laser was even level or anything like that. Maybe it was like shooting a pirate, because sometimes you can get an arch
wasn't the
upward.
Point, really. The point was that if the bottoms of the building disappeared, then the point where the laser was on would also disappear. You wouldn't be able to see where that laser was touching, because you wouldn't be able to see the bottom of the building.
All right, and so with his laser, it was reaching all the way across the fish tank. Okay.
Yeah.
Now, what would happen if there was more refraction in that fish tank? What would happen if the laser was able to have more distance? Imagine like a couple fish tanks with the same amount of refraction, kind of a much longer fish tank. So long as it's bending downward, it's eventually going to crash into the earth.
But it didn't bend down. That's the thing. You could see the laser touching the other side, so it didn't bend down.
Because the fish tank wasn't long enough.
It bent down when the laser was over a curved surface. That's when it bent down.
It was bending down, yes, and that's why you could see it but it wasn't. Okay,
right, give me one
that's
sec.
why I brought up the whole crazy Russian hacker one. You could see it hitting the bottom. Do you not understand that whole part about if no light can reach you, you're in darkness. You can't see the light.
Yeah, but as he presented, there's no reason why the light would be blocked off, because there's nothing to block it off. And also, more to the point, Kyle, the sun's in the sky, not at sea level. I mean, how high do you say the sun is?
I don't say how high the sun is. I don't know.
Right, but it's in the sky, right?
Yeah, as far as I can tell.
So why would, if it's in the sky, why would the light not reach us?
Because of refraction. The same concept of the things that, and it's not any amount of curvature. Curvature doesn't create refraction, okay?
No, it does. It actually does. That's a fact. The more curvature, the more gradiated the medium will be, which will cause more refraction. It's literally what causes refraction mostly. The reason we have the refractive conditions and effects we do is because the atmosphere is curved. And that means that light has to go through the different levels of density.
Right. You can look at just a basic fish tank with water in it, right? You can shine a light in a fish tank at an angle, and that light is going to get bent, even though the water is level.
Yeah, but that will be just one angle of incidence change, okay? That's going to go, down and then to the side. But if it's gradiated, you will get a curved laser, not just a laser that changes an angle. It's the gradation, it's the curve that causes that.
In order for that to happen.
Yeah, and that's why he put the curved surface in there. Because that curved surface was at the bottom, that would make the gradient of density due to the sugar also curved.
Okay, and if that were the case, according to you, the crazy Russian hacker would have had to have a curved surface at the bottom of his fish tank, but there is none to be seen.
Let me, can I see the crazy Russian hacker bit again?
Okay, I can actually pull it up for you, his actual video, but... Okay, where did our crazy Russian hacker go? All right, there is no curved... Wait, I've got to turn you back onto screen share.
Hey, Ranty, is that you or is it Brandon? I want to figure out which one of you's got a hard on for me.
All right. Looking at the bottom of this, there is no curved surface at the bottom of this fish tank. It's completely flat. And I can show you many other examples of people who've done the same sugar water experiment with no curved surface at the bottom of the fish tank that would cause the laser to get curved that way. That's not how refraction works.
All right, well, is that to do with the angle he is shining it through? if he's shining it completely straight, then it wouldn't do that. If you are shining it, not level, then it's going to go through a gradient.
It looks pretty level to me.
I mean, how level do you know it is? Because again, if you are looking directly on, you're looking through one level of density, and that's not going to cause much of a refractive change. But if the laser is slightly off of level, of completely flat, then it's going to be going through different layers of density, causing that.
Yeah. And so, if it's at an angle,
does he
wiggle and touching the Earth at an angle, then it's going to be like this. It's going to.
But
we're going to
light from the sun comes from all angles.
Yes, the light from the sun comes from all angles. Yes.
Yes, so it's not a laser. The sun isn't a laser. Light from the sun comes from all angles, not just a source point like a laser.
This represents one beam of light. Okay, just one beam of light. Right?
So what about the rest of the beams of light?
Huh?
What about the rest of the beams of light?
It's the same thing the moment they touch the atmosphere. And so long as the atmosphere is a gradiated atmosphere, it's all going to experience refraction. And so long as there's refraction in play, those light rays are not going to be parallel.
Right. Again, if there's a completely straight line there, does he wiggle the position of the laser at all?
He does in the actual video. I believe I've got an actual link to the video in the video's description. Let me pull that out. Crazy Russian hackers.
Think coding sounds boring?
Sorry guys, I put on
boring
slow mode now.
What did for like 24 hours? So I got a laser over here, and if I'm gonna put it to the aquarium water, look, you can see the latents are much better. So I put sugar over there, waited till it dissolved and settled down. So all the sugar water is on the bottom. Now let's see what happens if I'm gonna set the laser all the way down. Boom, look at this.
Very straight.
The laser bends. Why does the light bends with the sugar water on the bottom? Please let me know in the comments below how does this work. Pretty awesome, huh?
It looks pretty straight.
This water does not have any sugar, and if I'm gonna go up and down, you see light does not bend.
Where did you go? Okay, there we go.
Right. Now, what I would suggest with that is possibly he hasn't stirred it properly and there's more sugar water in the center than the outside. Honestly.
He just dumped it in there and left it for 24 hours.
Sorry, just one sec. I will line you up. Yeah, Ranty, your panelists are welcome to come to my channel. So, yeah. I'd have to watch the entire video. If there was more sugar water at the center, then it's going to create a curved gradient again. I would have to look at that. But if the laser is completely straight, going through a single layer of density, there is no reason for it to change. And I really want the video that I wanted to show you. This is the video I wanted to show you. Thank you, Glober Mum. Right, so let me bring this up. This is so what he's got is a tin, and he's put, as you can see, he's got a yellow bit of plasticine, a red bit, and a blue bit. Okay, yellow at the bottom, red in the middle, blue at the top. And he puts it behind this curved surface of that tank. So when you're looking straight on, let me get the camera set up. So you can just see the top of it, the blue that had on the top. Now, what he does next is pour a very cold gas on. I think it's butane, which has an ambient temperature, I think temperature of 0 degrees Celsius. And as he pours the cold liquid gas onto it, it creates the gradient, the curved gradient of density, and brings up what is behind the curve. So it's showing that it brings up things that are down. Let me do it again. So changing the gradient more, and it brings up the thing that is below the horizon in this case.
Okay.
That's what refraction does on a curved surface.
Mm-hmm.
So that was what I wanted to show you. That shows that on a curved surface, refraction will bring up something that is below the horizon.
And totally destroy any kind of claim to parallel light.
Not really when it's close to the surface. The sun isn't close to the surface. The sun is in the sky.
The sun is in the sky. Yeah.
Yes. So it doesn't have to go through much of a gradient, much of a density change when it's straight up coming in. But again, the sun is also, putting light in all directions, but it's more important about the angle you get from the shadow. Regardless of the refraction, when you map it all out, it shows you a globe and not a flat Earth. It gives you conflicting positions for the flat Earth.
Well, the conflicting positions totally make sense when you consider the atmosphere on the flat Earth.
Not really, because the atmosphere on the flat Earth isn't curved and wouldn't refract in the same way.
Have you seen the thing with the dome over the top of it?
Yeah, so that's a solid glass
dome. And most flat earthers believe in the firmament.
That's such a straw man because that's a solid glass dome and is not a representation of the atmosphere.
Well, I never said that the dome was a representation of the atmosphere. I said it was a representation of the dome.
Yeah, but the dome isn't solid all the way through, is it? There's apparently a dome and atmosphere. Well, that's a solid glass dome that he's using. So if you're trying to use that as an analogy, Kyle, that would mean that the dome...
No, I'm being literal. I'm not saying an analogy. Okay, we can put a big firmament over the top of it.
Yeah, so
solid.
Yeah, but we don't have a solid glass. It's not a dome. It's a semicircle that he's using. It's like a solid glass semicircle.
I'm aware of that.
It's not just a hollow dome like you would claim exists.
I never claimed that there was a hollow dome.
You just did you not?
No.
Well, what is your claim about the nature of the atmosphere then?
Well, I believe that the atmosphere is below the firmament, not inside it. Well, I guess it's kind of inside of it.
Where's the firmament?
Yeah, it's not like a bubble inside of it or anything like that. The firmament is a solid object up in the sky.
Could you point out the firmament to me in this video, please?
I can't see it.
Why not?
As far as I'm aware, the firmament is transparent. I don't know if I were to aim binoculars out the window or something like that. Can you show me where the window is when you're looking out the window with a pair of binoculars?
Usually you can see reflections and stuff.
Sometimes, but is that always the case?
There is simply no evidence of a dome of any kind there. And also, what would be the point of the dome?
Just because you're not aware of the evidence doesn't mean that there is none.
Well, we could just look at Hitchens' razor, can't we? Any claim presented without evidence can be dismissed without evidence.
Oh, I haven't presented any to you yet, but I definitely have a lot of evidence behind that. I just look at the ring effect. I don't know if you've studied into that.
The ring effect?
You know what the ring effect is?
The ring effect?
Have you heard of the term the ring effect?
Could you elaborate, possibly?
All right. So if I were to take a water balloon and throw it at a wall, okay, it's going to have a ring effect in slow motion. I've actually got a video about that. And so when we take the Operation Fishbowl nuclear explosions, right? Now, when they launched the nuclear explosions of Operation Fishbowl, they detonated before impact. And then after that, they go and smash up against the firmament, and you can see an observable ring effect that takes place just like throwing a water balloon at a wall, and it actually hits a solid surface. It creates the same effect.
Operation Fishbowl. 1 second. Cool, right, so Operation Fishbowl was about 35,000 feet.
I don't know that. Do you know that? I can't confirm that.
Yeah, I've just looked it up. Operation Fishbowl was confirmed to be at 35,000 feet.
That's what they say, but
confirmed by radar and everything. So this is above 35,000 feet. There's no firmament there.
None that you can see.
So did the balloon go through the firmament?
I didn't claim it did.
Well, this balloon is above the height of Operation Fishbowl. So that would mean it would be above the dome.
You haven't verified exactly how high Operation Fishbowl took place.
All data suggests it was between 30,000 and 35,000 feet. In fact, the maximum was 35,000 feet, between 9.1 and 10.7 kilometers.
Or so they say.
Right. So you've got no evidence it wasn't. Again, I have radar. I have documented radar stuff that I can bring up to show you the positions of everything.
Someone wrote down a number, and all of a sudden now we all have to expect.
Yeah, that's what records are, Kyle. I'm sorry, but denialism doesn't work on this channel. If you're claiming Operation Fishbowl, which was confirmed to be no higher than 35,000 feet, and they we're apparently going up against the firmament. You can have a look at the data yourself. That would be up to you. But this is higher.
The textbook says it.
This is higher.
Says it, therefore, it's true.
Yeah, I don't care about your your incredulity. That really doesn't matter. Facts are facts. Records are records. It would be up to you to falsify those records.
All about verifiability.
Yeah, it would be up to you to verify them. Not, I have all the verification here from radar measurements of the operations. So if you're claiming if you're claiming they're lying, that's for you to prove. Okay, but again, this is above Operation Fishbowl's height, and there is no dome. There is no.
I acknowledge your opinion on that. Okay,
not opinion. It's a fact. I don't have opinions, Kyle. I work only on facts.
Okay. I acknowledge your belief on that.
No, don't have beliefs. Beliefs are irrelevant. That's your deal. I don't do beliefs. I do verifiable facts.
Okay. Well, I acknowledge what you say about that. How's that?
Yeah. Okay. But it's a okay. Right. So how about the fact that it shows a curve? Just there's the curve there.
Okay. Yeah, there's a lot. This is kind of still new information. I'm still processing all that, but I would love to measure that and compare that. I'm all about measuring and comparing the x-axis with the z-axis. And if we can get those two to match up, then things can make sense. Because on a sphere, the x-axis should have the same amount of curvature as the z-axis does. And I think that's a little hard to do with this one, but I know with other elevations it's a little easier to do, but they never really match up. At least not that I've observed. But I'm always open to studying more on that.
Do you know what compressed perspective is?
Compressed perspective.
Yeah, you've got a degree in art, so
scrunched horizons. And
wait, hold on.
MC2, we had a great big conversation about that.
Yeah, you've got a degree in art, right? So surely you know what compressed perspective is.
Compressed perspective, and so that's where you take a photo and scrunch it down real quick.
No,
and
no, not at all. So if you look at this photo for this screenshot, for instance, right? Yeah. The closer to the bottom of the screen, more land will be covered by a small amount of pixels. Okay, as you get towards where the horizon is, there will be sorry, the other way around. There'll be less land for the certain amount of pixels. As you get to where the horizon is, more land will be covered by the same amount of pixels as towards the bottom of the screen, which creates a compressed perspective.
It's all whited out.
Yeah, but this is how anything works. Like the Lake Pontchartrain observations and everything, we're able to see that curve because of compressed perspective, because as you look further into the picture, more distance is taken up by the same amount of pixels. So it's called compressed perspective, which makes looking for a curve from angles like this quite hard unless you get the exact one like Soundly did.
Yeah. So one of the first things I'm going to test when really testing this image particularly is I want to know if it's got the same amount of curvature all the way across the screen here. Okay, all the way across. Because in some of the videos that MC Toon did, he had uneven amounts of curvature. So it was like totally flat on the right side, but it was really curved on the left side. And I did, yeah, that was part of my scrunched horizons, is we were getting some really strange looking
this one's pretty straight. I want where was the bit where he overlays the predicted curve? There's Mr. Sensible, and fair play to him that he went to all this trouble to do this, you know, off of his own back, you know, paid for the whole thing himself.
Yeah, that one, oh, right there, just right before that, I could definitely see it was looking very curved on the left side.
Yeah,
and
but
it wasn't looking so curved on the right side.
That's why he's got these reference line of where the barrel distortion would be. The blue and the yellow lines. Above and below that, there's going to be barrel distortion. Between the blue and the yellow line, there isn't. So you got to look at the...
So there's a lot more blue space here on the left than there is on the right here, as you can see. So that tells me that there's...
No, it's got grids. There's grids there, and there's about 3.5 grids on each side. 3.5 squares on each side.
Okay, but can you see the light blue margin of error? How that
margin
line
of error
is not marked. It's okay. So notice how that line, the black line there. Can you?
The calculated the calculated predictive curve, the black curve line.
The calculated predictive curve.
Yeah.
Okay. Notice how there is a bigger difference on the left side than there is on the right side.
There isn't. There's grid references to show you that there isn't.
You don't see the blue, the light blue here on the side.
I see what you mean. The blue of the atmosphere is slightly more up on the left compared to the predicted one.
It's higher on the left than it is on the right. That tells me that there's some uneven curvature going on here.
Yeah, well, you can go through I could even get you the entire unedited footage, so you can go through it and look for completely flat spots yourself. Okay. But no matter how much it curves to the tilts to the left or the right, when it's in between the blue and the yellow line, the horizon is always convex, not concave or flat, always, and it matches what we should see based on predictions.
Okay, and so like I said, it really comes down to measuring to see if it's got the same amount of curvature all the way across, or if there's uneven parts where it's
the same for this one for the dog cam. You can look at the videos yourself again and do all the measurements you want. But these are from space, where there's clearly no dome. And I want to talk about the dome in a bit, but first of all, I wanted to ask.
Are you saying the dog cam is past the thermosphere?
It's certainly past what Operation Fishbowl was.
Surviving the thermosphere?
Why wouldn't it?
Because of all of the intense amounts of radiation in the thermosphere.
What kind of radiation?
Would totally melted down. I don't see any kind of air conditioning on that thing.
What kind of radiation do you mean?
Solar radiation.
And why would that melt it down?
Why would the sun melt down the dog cam here? If it's in the thermosphere, okay, the amounts of solar radiation are really, really intense because of all of the atmospheric reflection.
And you think that should just melt everything?
Huh?
Why would it melt everything?
Because it's hot.
Why?
Radiation. It's got a lot of.
What do you mean solar radiation is hot? That's not how it works.
It can't just get rid of that energy fast enough.
You know that it's still within Earth's magnetosphere, right? Which takes away most of the radiation from the sun.
The magnetosphere.
Yeah.
The magnetosphere that's above the thermosphere, isn't it?
It's a lot bigger than Earth. And also, I don't think you know how energy transfer works. That's quite interesting.
Well, I've got a great video here that specifically talks about this in much more detail about this whole issue with the satellites. And I just think about hot metal slides on a playground. It's not the air that's making that hot metal slide, or the metal on the slide hot. It's the solar radiation. And so if the solar radiation can make a slide hot enough to give a kid, intense burns, and that's way down here in the troposphere, then way up there in the thermosphere where there isn't as much of that protection.
And you think it should just melt metal and plastic and stuff, do you?
It's going to get a lot hotter than it is. And so
you realize that a lot of the heat that we get from radiation is because of the interaction with the energy coming from the sun and our atmosphere, right?
Well, I understand that the atmosphere, it does have a lot of heat in it, but it's the atmosphere is not what made
hilarious.
It's 90 degrees out. Okay, it can be hot. It can even be like 100 degrees out. But the hot metal slides can get way hotter. You're not going out there and totally burning to a crisp.
Let me ask you a quick question. Where is it hotter, at the bottom of a mountain or the top of a mountain?
Generally, it's in the bottom of the mountain. Yeah.
Right. So you're a lot colder when
but that doesn't mean you can't get
wait,
sunburned.
hold on.
Get a lot easier. It's a lot easier to get sunburned on the top of the mountain.
Yeah, but sunburn doesn't melt you.
It doesn't?
No, it damages your skin. UV radiation doesn't melt metal and stuff. But you were saying about it being hotter and stuff. But it's not hotter. It's not how it works. Like,
it's burning you, isn't it?
Yeah, that's radiation interacting with the cells in your skin.
Mm-hmm.
That's not how any of this works, Kyle. Can I just ask? This is quite an important question. What is your science education level, like physics?
Well, I've got a bachelor's degree. I've got a great video about my full disclosure.
You've got a degree in art.
It's science in art, and so you have to understand what the definition of science is.
Yeah, it's nothing to do with actual science. It doesn't mean that you know anything about physics or anything. You did a degree in art, not anything to do with actual science, like...
You actually have to take physics in order to get a degree in art. That was yeah.
You have to take physics?
Huh?
You have to take
physics? Was part of it was a required course.
What's the derivation of x squared?
The derivation of x squared?
The derivation of x squared.
I don't know.
Right, you never took physics then?
I did.
Then you would know the answer to that question.
But I did.
Wow. Right. Moving swiftly on to your... you don't need to talk about your non-science degree. You didn't study physics, Kyle.
Are you trying to attack me here, or are you trying?
No, I'm trying to say that you don't need to tell me that you studied physics when you didn't. You don't have a degree in science. You have a degree in art.
This is an ad hominem attack, is what you're doing.
No, it's not. I asked you what your science background was, and you said you've got a science degree.
If you're the only reason you're bringing
No. It's important because I need to know what level of physics I need to explain to you, Kyle.
Well, there's not just me here, but we've got a lot of audience here too.
Yeah, there's nearly 800 people watching, and I'm just wondering, for their sake, how much I need to dumb this down.
I don't know.
I mean, just so you're aware of my qualifications, Kyle. I've got 2 BScs. One of them is in physics. One of them is in nuclear engineering, energy systems, and fission technology.
Excellent.
So, which one of us do you think is more qualified to talk about things like the thermosphere?
The person who has the most ability to verify what they say.
And do you think that would be you or me? Which one of us would have the knowledge and ability to verify these things, you or me?
Do you really need knowledge and ability to verify it, to show an observation?
Yes, to understand it, absolutely.
I let the observations speak for themselves. I can show you...
If you can't understand the observations because you don't have any knowledge of physics...
the flat fish tank with no curvature on the inside, and you can see the light bending. That's an easy thing. I could show you just
All right.
glass.
PhD Tony,
a solid
give me
chunk of glass and light getting refracted in that glass, even though that glass is not spherical.
one sec. PhD Tony, give me a 1 to 10 on how much I need to dumb it down. I was just a bit stunned by your comments on the thermos, so we can get back to your misunderstanding of energy transfer. But the other bit of evidence that I brought up is this image, which is, let's face it, Kyle, 100% impossible on a flat Earth.
Why so? Are you taking the atmosphere into account?
Yeah, the lapse rate up there is tiny.
The what?
Wait, you're talking about refraction and you don't know what a lapse rate is?
The lapse rate.
Yeah.
Okay, so camera height above sea level is 210 meters above sea level. Bridge tower height. Okay, only one. Why? I don't get it.
Those hills in the background.
You're talking about because the one appears lower than the other two.
No. We're just using the one in the middle as a reference. We're just using the one in the middle as a reference.
Because that one appears higher, all of a sudden that means
no. Kyle, stop. Hold on. We're not looking at the two pillars to either side. We're just looking at the pillar in the middle that is the same height as the camera. And then we're looking at the hills in the background, which are about 47 kilometers north of Edinburgh. And those hills, all of them, are more than 500 meters above sea level.
Yeah.
So there's no reason, any reason at all, they would drop below the eye line of the camera. Perspective doesn't do that. Refractive effects up that high looking on a tangent are going to be minimal. Certainly not enough to take off more than 50% of the mountains really high up above sea level. This image is impossible on a flat Earth.
You're going to have to do more to persuade me that is not...
No, you're going to have to explain how this is possible.
See, refraction, when
refraction can't do this, Kyle. Kyle, refraction cannot do this.
Farther.
Kyle, refraction cannot do this.
We can't see as far.
Yeah. Refraction cannot bring something below a tangent eye line. Not like this. Not when you are away from the refractive conditions that you get close to the water. Up at 210 meters above sea level, looking straight out, you're going to have the most minimal of refractive conditions. Minimal.
I would like to see you explain that further and with some additional observations to support you on
Where's the rest of the mountains, Kyle?
They're refracted out of view.
Yeah, refraction doesn't do that. Refraction also, as I've demonstrated with the video, brings things up from a curve, not pushes them down.
And I just showed you a video of them getting compressed out of view.
Not below the eye line, though.
You were seeing them. It was compressed out of view. Okay, and so if those farther away mountains are getting compressed more, than the ones in front, you're not going to see them.
In this later on in this video, or maybe somebody else did it. They actually overlaid the mountains there, and there is no compression of the mountains. Actually, when you overlay what the mountains actually are, the proportions stay exactly the same. There is no compression.
There's no compression.
No.
When you overlay mountains and
you can overlay the actual images of the mountains, the skyline of the mountains, and it shows that there's no compression. There's no alteration of the proportions. The mountains are not compressed 50%. That's not how it works. Just denying it is pretty intellectually dishonest. And then again,
I'm just asking you to back it up here, because all I've got is one picture.
But it's not that one picture. That comes from an entire video. And again, this is from the same video looking 180 degrees in the opposite direction with the same thing. 210 meter eye line, hills in the background, 1,000 meters above sea level, with proportions as they should be, dropping below eye level. Completely impossible on a flat Earth. Those hills should be above that red line. And even better, right? Walter Bislin mapped them out, right? What you would expect to see on the globe model, which is what we see, versus what you would expect to see on a flat Earth model.
I wonder where his atmosphere is.
It's all taken into account on his
flat Earth model.
It's all taken into account on Walter Bislin's calculators. Walter Bislin's calculators are some of the best tools that you can use to look at what refractive conditions you should have. And this is with the atmosphere all taken into account. What we expect to see on the right matches what we do. Predictions.
Okay.
If a model can make predictions and those predictions are correct, then we should adopt that model as representing reality. There is no predictions that a flat Earth model makes that match reality.
Oh, you haven't seen my channel very much. I make a lot of predictions.
Yes, I have. Oh, don't worry. Flerfs are idiots will be getting a Kyle Adams episode. Do not worry.
I make a lot of predictions.
You think you do?
I test them.
You think you
just
do?
Just like I did
Kyle?
with the other one.
Kyle,
in that one video, we did the hypothesis, we did the test, and we confirmed our predictions.
It's hilarious that you think that's what you did, but there will be a video covering that. My goodness.
Okay.
So these are things that are impossible on a flat Earth. It's modeled out, including atmosphere, shows that things you shouldn't see. But then what about the other things I brought up? The fact that we can measure the rotation of the Earth. Easily done by the gentleman physicist.
Okay.
How are we getting those effects of a drifting pendulum if the Earth isn't rotating?
You do realize that it's all that the Foucault's pendulum and I'm trying to think of my words here about. I can use my hands. I'm a very visual person. So I see things with pictures, and I've got to do my best to articulate them and put them into words.
That's cool.
And so, okay, you got a ball, okay, and the force is going to end up going out, okay, out and over. That's what the thing. That's what it does, and.
What?
I'm at a loss for words. I'm sorry about that. That's where I do better with writing than I do with in-person speaking.
Okay, so maybe I need to clarify what he did, right? He used the drift that he got to calculate his own latitude.
Today we get to play with Foucault's pendulum.
So, after letting it swing, all right, now, if the Earth is rotating, the effect that we expect to happen is that there should be a drift clockwise. That's the first thing that was verified. There was a drift clockwise. If you're in the southern hemisphere, it would drift the other way. The prediction of it drifting that way was based on being in the northern hemisphere, and it was correct. And then the amount of drift was measured. They got the angle from it. And then they used that angle and did a bit of trigonometry to figure out what their latitude should be based on the amount of drift that it had. And it matched their latitude in real life. So that effect that happened and the angle that was gathered are things that are expected if the Earth is rotating. This matches our model. This matches our predictions exactly. That effect needs to be explained if the Earth is flat and non-rotating.
Okay.
So how is it explained?
How is the moving explained?
How is the drift?
I'll have to come back. Huh?
How is the drift explained? How is the fact that it drifted a predicted amount explained if the Earth is flat and non-rotating? What causes that effect? Where is the force? Where is the acceleration coming from to cause that change in direction? What happens?
It's a pseudo force.
But you see it physically doing something, right? It physically changes the drift. It physically changes the direction. Calling it a pseudo-force...
pseudo-force changes the drift.
Yeah, because you do understand that a pseudo-force doesn't mean it doesn't exist, right?
What does pseudo mean?
Pseudo doesn't mean it doesn't exist. It's just a way of describing... It's a way of describing an apparent force within an inertial reference frame. But you cannot deny that there is a calculable force there because of the drift that happened, right? It's a physical thing. You could see it happening. And that is the effect that we expect to happen.
Okay, so a pseudo force means it's a false force, right?
No.
And so
a pseudo force means it's an emergent property of something else happening. It means it's not
something else is happening. Thank you.
Yes.
Something else is happening,
Yeah,
but
and
it's not.
In this case, it's the rotation of the Earth that is causing the apparent force that makes that deflect.
The rotation of the Earth is causing the effect, and so it's not the force itself, but it's the rotation of the Earth, as you're saying.
The rotation of the Earth is what causes the apparent force that causes that drift. It's
Isn't the drift going in the wrong direction?
No.
Shouldn't it be going upward?
What do you mean upward?
Okay, well...
The drift would be either clockwise or anti-clockwise. If you were at the equator, you would get no drift. If you were at the poles, you would get 360 degrees in 24 hours.
Okay, if I were to
360 degrees an hour, sorry.
A ball on a string, for example, and if I were to swing around in a circle, if I were to swing around in a circle, that is going to be pulled outward. Okay, it's not going to be going.
Yeah, that's called centrifugal force.
The directions here. Okay, it's not going to be going to on the z-axis or anything like that. It's going to be going outward. So why is this saying it's going on the z-axis instead of going that way?
Wait. Okay, centrifugal force is something on Earth that acts in the opposite direction to gravity. That's not going to affect the drift on a tangential plane to the Earth.
Why is it causing it to curve?
It's right. It is drifting because the Earth is physically rotating underneath the swinging pendulum.
Okay,
that is,
so
and again, Kyle, what you're missing out here is
explains why it would be moving outward.
No, not upward. The centrifugal force pushing upwards at his latitude is so small, so small. The rotation of the Earth is imparting the Coriolis effect onto that. It's not going to be a direct correlation to how fast the Earth has a tangential speed at a certain latitude. What you get is a drift because the Earth physically rotates underneath the swinging pendulum. And the model that we have suggests that this is the effect that you should get. The maths backs it up. The centrifugal force acting in the opposite direction because of the rotation of the Earth isn't what you're taking into account here. That is, at his latitude, like 0.02% of the downward gravitational acceleration.
Okay, so if I were to take my ball on a string and spin it around me, the centrifugal force of me spinning the ball around me is going to cause the ball to spin around like this while it's going around, right?
Yeah, so what is the centrifugal force on that ball compared to the centrifugal force on the pendulum? Which is going to have more?
Neither, because it doesn't exist. It's a pseudo force.
It's a
pseudo force means a false force.
So you don't understand what a pseudo force means. Is it a calculable thing or not?
Is a pseudo force something that does not exist calculable? No.
So you've no idea what a pseudo force is. Of course you can fucking calculate what centrifugal...
Sorry,
I apologize.
You're swearing at me now.
Frack.
I don't go that way.
I apologize. Like I said, it's going to slip out. But no. Centrifugal force is a very...
yelling match.
Okay, Kyle, chill. Centrifugal force is a very real thing that is calculable. You can calculate what the centrifugal force is. There's a formula to calculate centrifugal force. Just because it's called a pseudo force doesn't mean that it's not a calculable thing that has physical consequences.
Okay. So this brings up, the whole calculable. Because it's calculable, that means it is this. Okay. And so I had a great conversation.
It's simple. I
had a great conversation about this. Okay. If I were to come home from work every morning and say, okay, I predict that my freezer is going to be hanging open and all the food is going to be missing. I predict that. Therefore, it was Bigfoot. Bigfoot came into my house.
Yeah, that's a total straw man.
Everything out and left it all over the thing. Just because I can predict it, does that mean Bigfoot did it?
Can you mathematically show it?
I can come up with a long list of predictions.
Kyle, you're using straw man here. You're using straw man and completely false analogies.
You're telling me about
no, absolutely is. Yeah.
Predictions.
Yeah, calculate a prediction is something that is testable, right?
Okay, and so I could test that. Okay?
Yeah, but you cannot math. Kyle, hold on. Kyle, stop. Test that. Kyle, stop. You cannot mathematically calculate that Bigfoot is going to come to your house. You can make a hold on. You can make a wild guess. That is not a prediction as such. Not a mathematical prediction based on a working model. That's not how it works. What you're saying is complete nonsense. What we have here is an effect that we expect to happen if the Earth is rotating. The physics of the known universe say that this should happen at this latitude if the Earth is rotating. The flat Earth needs to explain where that force comes from, all right? There is a mass, right? This is how simple I need to make it. F equals ma. There is a mass. The mass accelerates, therefore there is a force. Do you understand? Do you agree with that?
That the mass accelerates, therefore there's a force.
Yes.
Something can't go without something pushing it, or a force acting on it.
Do you agree that F equals ma?
Yeah.
Right, okay, exactly.
Force equals mass times acceleration.
So, there's a mass, the pendulum, right? It has accelerated to a different position because it's drifted. Therefore, there is a force imparted. The force is called a pseudo force, or whatever other terminology can be used for it. But that doesn't mean that it doesn't have physical consequences and isn't something that is calculated and expected. If a mass accelerates, there's a force. There's not really a physical force. It's a consequence of something else happening. In this case, the rotation of the Earth imparting the Coriolis force onto the pendulum, making it drift the predicted amount.
Another pseudo force.
Sorry? Yeah, the force that we are talking about is the Coriolis force. That is the force that we are talking about. Again, doesn't mean that it doesn't physically exist and can't be observed and calculated.
That's exactly what pseudo means.
No, it doesn't. You don't understand anything about physics, Kyle. As I just explained to you.
Okay, you're
there
just
is a mass.
You're throwing more insults at me.
No. That's a fact. It's not an insult, Kyle. You don't understand physics if you're saying pseudo forces don't exist. They are real calculable things. Centrifugal acceleration, it's there. It pins you to stuff. All right. But that is a result of the centripetal acceleration.
Thing. I can tell you a lot
no, straw man.
Okay, well,
no, you cannot mathematically, Kyle. You cannot Kyle, stop. Kyle, stop. You cannot mathematically calculate and predict for Bigfoot coming into your house.
I can calculate. Okay, well.
Please show me the maths. Please show me the maths.
Yardstick is.
No, wait, hold on. Right, you are making a claim. I would like to see the working model and the maths based upon that will predict Bigfoot coming into your house.
I was just saying that I can tell you that. Okay, well, I'm going to see exactly this many cans outside of the cupboard, and just because I'm going to protect 5 cans, and if I were to see 5 cans come out of the cupboard every morning when I get home from work, I could say, oh, well, that's Bigfoot. But that doesn't mean it was actually Bigfoot. It just means that there was something taking the cans out of my cupboard in a precise manner every single morning. Okay?
Yeah, that's not how any of this works.
There's a lot of things, but that doesn't mean it was Bigfoot.
But is there a working model that you can mathematically show me that this is happening? Or are you just making things up? Because a pseudo force isn't making things up. It's also called a fictitious force, or the Ambert force, or inertial force. It's a force that appears to act.
Fictitious force. It is fictitious.
But that doesn't mean
exactly
it doesn't.
What it means.
Yeah, but it doesn't mean it doesn't exist. That's just a technical.
It
no, it doesn't, Kyle. And this is how I know you know nothing about physics. It's not an insult. You genuinely know nothing about physics if you think pseudo forces aren't there. It is a pseudo force that has caused this mass to accelerate. That means that there is something there. All right. It's a force that appears to act on a mass whose motion is described using a non-inertial reference frame of reference, such as an accelerating or rotating reference frame. An example is seen in a passenger vehicle that is accelerating in the forward direction. Passengers perceive that they are acted upon by a force in the rearward direction, pushing them back into their seats. And they're not. There is no force pushing them back into their seats. It's just the fact that the car is accelerated forward. That doesn't mean that you cannot calculate the force that has pushed them back into their seat. There's a mass that accelerated, therefore there is a force. It's as simple as that. And Coriolis is exactly the same, right? Coriolis is called a fictitious force because there's not a physical force. It's a consequence of something else happening, right? It's It's a change in reference frame, and in this case, the conservation of momentum that causes the deviation. Coriolis causes things to deviate from a path. That means that the mass is accelerated. Therefore, there is a calculable force. A pseudo force, Kyle, and you just need to accept this as fact. You can ask anyone in the world that has any qualifications in physics. A pseudo force or a fictitious force does not mean it does not exist.
Okay, so you're making an appeal to
facts.
It's an ad populum argument here.
No, it's not. It's just the facts. It's how physics works.
That's an ad populum. Ask
No,
anyone.
no, it's
Ask
not.
anyone.
No,
That
Kyle,
means-
no. Stating facts is not ad populum. Anybody in the world that has passed a physics course knows that a pseudo force doesn't mean it's not something that is there that is calculable. That's just not what it means. You are just wrong in that assertion.
Okay, I hear you on that. I've heard what you've said about that. That doesn't mean I agree with you.
Well, you're wrong though. Again, I've got a degree in physics. I've studied this.
I can say the same thing about you, but I can say
you're wrong. But you've got no way to... Kyle, I've studied physics, so I can tell you that you're wrong. You haven't studied physics. You don't know what pseudo forces are.
Oh, okay, so now you're making an appeal to an authority.
No, I'm stating a fact.
Matter,
I'm stating a fact.
Because I have the...
Kyle, fallacy, stop with the fallacies, all right? It makes you look dumber than you are. Honestly.
Oh, really? Now?
Yes.
Okay, now you're calling me dumb now. Okay,
yeah,
so
it's a fact you think the Earth is flat. Wait, you don't even know what an ad hom is? That's amazing. Are you going to get all the fallacies
wrong?
When
you attack a person rather than their argument.
Yeah, I didn't say you're an idiot, therefore you're a flat earther or anything. I just said you're an idiot. That's not an ad hom. That's just a straight up insult. There's a very big difference. Please learn your fallacies, because the only fallacy that's happened... I wasn't even taking your argument into account. If I say you are wrong, you're an idiot, therefore you're wrong, you're a flat earther, therefore you're wrong, that's an ad hom, right? Saying you're an idiot, that's not an ad hom, it's a straight up insult. Please learn your fallacies.
Oh, I'm very well aware of my fallacies.
No, you're not. You're just as well as your fallacies as you are at your physics, dude.
Oh, really?
Yeah.
So, okay.
You know, why would you think you know more about physics? Kyle, why would you think you know more about physics than people that have studied physics?
I just go with the verifiability. That's it.
Okay, and here we have a verified fact based on a model that with predictive capabilities. This is an effect we expect to happen. If the Earth is rotating, all known physics say that this should happen, and it does. That needs to be explained if the Earth is flat.
It's a Bigfoot. Okay,
no, it's not. It's a fact. It's something that we expect to happen.
Therefore, it's the curvature. It's the spin of the Earth.
I'm saying.
Say, okay, well, this many cans came out of my cupboard. There's a force moving these cans out of my cupboard.
Do you want to take those goalposts any further away? Perhaps up to the dome at 35,000 feet that the balloon went past?
Why are you changing the subject?
You're changing the subject by talking about Bigfoot. I am talking about the predicted effect that is supposed to happen according to all known laws of physics if the Earth is rotating.
I'm just saying it's a Bigfoot.
It's not a Bigfoot.
Situation.
It's not a Bigfoot
situation.
No.
This is Kyle. Every morning. Therefore, there's a force acting it that's very measurable. Therefore, it's Bigfoot. That's what you're saying.
No, you're just making stuff up. Yeah, this is verified. Kyle, shut up for a second, all right? This is verifiable. This is something that should happen if the Earth is rotating. What don't you understand about that? This is, if physics says that if the Earth is rotating, this is what should happen, all right? So our model and the globe Earth says that this should happen, and it does. All right, instead of just going, it's a Bigfoot, you need to explain how it happens if the Earth is flat and non-rotating, instead of just trying to ignore the evidence that is in front of you.
You just showed me a force that's causing it to move.
Yes.
Okay? You have not connected that this force is actually caused by the spin of the Earth.
It's exactly caused by the. No! Stop! That's exactly what we did.
I'm trying to talk to you, and you're interrupting me.
You're building false premises on top of false premises. So if you get to one false premise, I need to stop you to correct you. We absolutely demonstrated this is due to the rotation of the Earth, because the rotation of the Earth would impart this drift that would allow you to calculate your latitude. That is what we expect if the Earth is rotating. If you go to the southern hemisphere, it will rotate in the other direction exactly as we expect. All right? This is what would happen if the Earth is rotating. So you need to explain how it happens if the Earth is flat and non-rotating. Let's stick with that, okay?
There's a lot of other things that could
like
happen.
what? Like what? What is causing that predicted drift?
Okay,
Please explain how magnetism would be moving that big concrete block.
How magnetism can move. So you want me to explain
where's the magnetism coming from?
You're gonna have to
where's the no? You've just said magnetism is causing that. That is a big claim. Where's your evidence that magnetism is causing a drift that is expected due to the rotation of the Earth?
We could pull up magnetic field lines of the entire world, and then we can compare that.
And how would the magnetic field lines cause a predicted drift based on rotation?
Who said it? Okay, so what happens a lot of times, what we get is where, just like this pseudo force, okay, where one thing is actually doing it, but then they just kind of say, oh, well, it's actually this doing it when this.
Yeah, it's called emergent. Do you know what the word emergent means?
Huh?
Do you know what the word emergent means?
Emergent. To break forth, to emerge, to
oh my
to
God,
come
you're
forth.
so dumb. No, emergent as in a consequence of something else.
Okay.
We refer to these things as emergent forces, emergent properties of other things happening. You know, it's like saying, did switching on the light switch, did that cause the light to come on? It might seem that way, right? You press the light switch and your lights come on, but there's a lot more that's actually happening, isn't there? It's connected a circuit, allowing a current and voltage to travel around the connected circuit that's coming from wherever the generation is coming from, that then activates the light. It's not just pressing the switch causes the light. Pressing the switch causes something else to happen, which causes the light.
A chain of reactions, yes.
Yeah,
yes.
And it's the same. It's the same concept with inertial forces. Right? I don't like using the term fictitious force. I like to call them inertial forces because that's a much better description of what they are. Right? An inertial force is
they're fictitious.
But no, they're inertial. Right? And again, fictitious in this case doesn't mean they're not real. Right? You need to look up what the term fictitious force actually means instead of just concentrating on the word fictitious, because it doesn't mean it. Yeah, but it's also
they described it that way.
Yeah, and have you studied as to why they described it that way?
Yes.
Well, then you wouldn't say that it isn't a thing, Kyle. You just lied to me. You haven't studied it because you wouldn't have said that. Right?
I've studied it, and I've learned about why it is, and that's what I learned.
What other names is there for it then?
There's a long list of names. Should we go pull up Wikipedia and read the long list of names? We can do that.
And why is it called an inertial force then? What does that mean?
Why is it called an inertial force?
Yeah.
Well, the inertial force is describing the inertia when something gets going, okay? And so it's moving, is it not? We can go into more details on that. I can pull up the thing. I don't have everything memorized. I'm sorry.
This is what I mean. You don't know anything about physics, Kyle, because you're saying all the wrong things about what forces are. A pseudo force is a calculable thing that has a real world consequence. Centrifugal force, gravity, Coriolis, they're all emergent forces. They're all inertial forces, but they have real things that happen. You know, pseudo force, fictitious force doesn't mean that it's not real. It's a calculable thing that is actually there. And I'm just going to take that as a concession that you have no idea how this would happen on a flat Earth, because there is no explanation for how this would happen on a flat Earth and how it would correlate to exactly your latitude on the Earth.
I recall there's quite a few flat earthers who talk about this, and so you can't say there's no explanation when there's a lot of videos out there providing
there is no explanation for this. There is none. None at all.
You're just denying every explanation out there and saying,
no. The attempts at explanations are completely wrong based on a zero knowledge of physics. Making shit up is not an explanation.
Okay, now you're cursing some more. Okay.
Oh, come on. Please remember that I live in Scotland and swearing is simply part of my lexicon here, okay? If you ever speak to a Scottish person...
enormous amounts of disrespect right now, and I'm just like...
Not really. Like I said, you have to understand that that is literally how we talk in Scotland. Every other word is a swear word. And actually, swearing is scientifically shown to be done by people with a higher intelligence and a larger lexicon. So, if the odd swear word slips out, then don't take it as an offence to you. Just take it as the fact that I live in Scotland and I'm married to a feisty, red-headed Scottish woman. All right?
I understand that. Okay? But there's a lot of things that's going on through your tone. Okay? Just your tone.
Oh, frustration with how little you understand about physics.
Angry, okay? And you're dishing out a lot of insults towards me.
You are. I mean, Kyle, this is an objective fact. You're not very smart. You don't have any knowledge about physics. Are you just going to run away? Oh, he did run away. Oh my goodness. Oh, that definitely counts as a rage quit, right, guys? He didn't like the... Oh yeah, I'm going to send Team a link. Give me a sec. Now, video call. I hope you enjoyed that, guys. I had fun. Not going to lie, I need to look at the explanation for the bending of the laser in the non-gradiated thing. I think I may do a video about that. Let's have a little bit of an after show, shall we? Oh, bloody hell, I didn't even fucking copy the link. My brain stopped working, bear with me. I mean, I was trying to be nice then. I was like, Kyle, speaking real, you're not very smart. Was that mean, guys? Was that too mean? I don't know. Okay, here we go. What do you reckon, guys? Was I too mean? Number one, I was too mean. Number two, I should have been a lot meaner. Let me know. We get Team on and have a little chat, and I'll read out super chats. Wednesday, I have Flatzoid coming to talk to me, which should be fun. He's one of Nathan Oakley's cronies. Make sure Team's audio is on. Thank you guys for all the super chats and the support. As always, you are absolutely amazing. I didn't even get a chance to ask him the litmus questions. Damn it, that was coming up. He is the king of Dunning-Kruger, I think. Literally knows nothing about anything. People think I should have been a lot meaner. Yeah. But he told me beforehand that if I dropped F-bombs, he would leave. And I thought I was pretty good. I really tried to control my language, but the frustration started to build when he just starts denying and then just says magnetism. It's nuh-uh, here's this evidence. Nuh-uh, here's this evidence. Nuh-uh, here's this evidence. Nuh-uh. And his only evidence was Mick West proving that the Earth's a globe. I mean, did he realize that? Team, did I send you the code? Oh, he's loading up. I think I'd like to call this guy JM Light. All right, let me read some super chats while we're waiting for Sket Bitch to come in. JL Warren for $4.99 says, how do you justify the historicity of the Book of Mormon when no evidence exists of the connections asserted? JM, I will give you his contact details. I would love to see a debate between you and him about Mormon stuff. And we've got Technomancer Magus became a new member. Thank you very much. You can use new emojis of Vlad Blobfish, Team Skeptic in a Mankini, and Nathan Thompson in jail. Team, you there? I do have him. Yep, he's definitely unmuted. He's probably just sorting out his thing. Christopher Hugan, my PayPal link is paypal.me/FTFE.
Yo, can you hear me?
Oh, yes. Hello, and some loud music. What happened there?
Loud music?
Are you running through voice box thing? You've got like a background music playing, I think. You're playing that speech music. That's what it is.
Is it? Oh, yeah, it was playing.
Man.
Yeah,
dude,
so...
I tried so hard not to swear. I tried so hard.
I mean, fuck that guy.
I don't want to.
Oh! No, yeah, you should. Get fucking beard hair everywhere.
What do you reckon about JM Light as his name? Because he's from the same area, and he calls himself a professor and stuff, just like JM does.
Oh, he did say that he has an art degree he had to take physics to get. What?
Let me get up a video.
I mean, he might have taken physics. Yeah, he might have taken physics as like a science elective to qualify for a bachelor's degree, but that doesn't mean anything. No, he never took physics. If he doesn't understand what a fucking fictitious force is or a pseudo force is, then he didn't take upper level physics.
That I started to get frustrated when he just wouldn't accept the definition of a pseudo force. Like,
yeah.
Yeah, so this is his degree, team.
Hold on. Let me pull you up.
Oh. Sorry. Go away, Mr. Sensible. You're awesome, but...
Damn, his degree looks like a bald human being. That's crazy.
Yeah, that's his degree. Bachelor of Science in Art, with an emphasis on painting and drawing.
If he got a master's, it would say, hey, if he really got a master's, it would say fucking finger painting and line drawing. You know, without a master's, it just says painting and drawing. With a master's, it would say finger painting and line drawing emphasis. With a doctorate in finger painting.
Why, like, does he honestly think that this gives him a right to talk about physics and stuff? And I don't like doing the whole, well, I've got a degree in physics and you don't, but it kind of has to be brought up because I studied physics, you know? PhD Tony, he studied physics. Clive Wells, he studied physics, right? We've looked into that. So why does someone like this come along and think that they've got the authority or even, you know, the right to tell us that we're wrong about physics when we're the ones that have studied it? I mean, it honestly does frustrate me.
I have no idea.
I'm not being rude, am I?
I'm
not being like big-headed or anything with that, am I?
No.
But
no.
I mean, I wouldn't go to him and tell him that I'd be better at drawing some pictures because you know what? I fucking suck at painting and drawing. Obviously, he's pretty good. He's got a degree in it. But that doesn't mean that he knows what the fucking thermosphere is or what solar radiation would do to metal.
Yeah, right.
Oh my god. But did you see the bit where he was showing the laser bending in the flat bit?
Oh yeah, with the sugar water.
Yeah. Why was it bending when there was no curved surface in
it? Because there's a gradient inside of the water of sugar.
Yeah,
all the sugar's at the bottom. Okay, hold on. Think of it like this, right? Let's say you could magically take a drop of water from the bottom and a drop of water from the top. All right? Now, you'd put both let's say you did it individually on your tongue. You'd put both drops on and say, one of them has more sugar in it than the other one, right?
Yeah.
You understand what I'm saying, right? There's more sugar at the bottom than there is at the top. But would the water at the top taste like water that didn't have sugar in it? Or would it still have a slight sugar taste to it?
it would still have a slight sugar taste. But my point
Right.
is,
So there's a gradient of sugar. The
Yeah, yeah.
density of sugar is a gradient all the way down. That is why the laser bends, because it's going
of
to
course
always
not.
have a tendency to bead in the down direction.
Yeah.
Because even though you might have like, let's say you have a situation where it's slightly at the very, very tiny level, you know, it's slightly
Right.
more dense up. Well, the laser would kind of rise up, but here's the thing: if you add up all the density across the whole thing, there's a tendency for it always to be more dense underneath. Therefore, the light will begin to bend. It's similar to if you were to draw glass out with a different density.
Yeah.
That would be the angle of incidence that you would need to get the light to start to bending,
But
because there is
I
a gradient of sugar throughout the container.
I forgot that even looking through a layer of density, refraction will still push it down slightly, even if it's just one layer, without it going through the gradients. Because
No. Okay, so that's where the problem is if, let's say it was perfectly flat, and let's say the beam was perfectly level, and let's say that the water, like the gradient of the water, is such that every layer of the water, okay, let's just say that every single layer is perfectly isotropic, okay? So that means that at every point that the laser could go through, the water at that point was completely isotropic, meaning the same density above is the same density below, and there was a perfect zero angle of incidence. The line wouldn't bend. The light wouldn't bend through that. But because we can't guarantee that there's always going to be an isotropic medium regarding density in this situation, because we can't guarantee that, and mathematically speaking, because of gravity, we have a tendency for there to always be more dense water underneath than what you're going to have is when you do that thing.
So
as you bring it down, it gets.
So if the
Go ahead.
laser is completely flat, then it's less likely to bend. Obviously.
No,
Because-
there has to be a gradient. There has to be zero gradient in the water. In the water. There has to be a zero gradient. It must be perfect for there to be no bending
if
of
the
the light.
laser is shining straight through, and along the entire length of the laser, the density and temperature doesn't change, then there's going to be practically no refraction, right? But if, for instance, that laser was slightly off and aiming up a little bit, then that means
A little bit, even a little bit would cause the light to begin to bend.
That was what I was saying to him, right? But I felt a bit of a cop out saying that. I want to figure out how to better articulate my argument against that. But the video that I showed of, bringing the horizon up with the tin kind of refutes what he's saying anyway, right?
No, it's a good example of it. I mean, it's still a good example. I'm not saying that it's not, it's not a good example. It just doesn't refute what he says. What refutes what he says is you just have to explain to him that it's a gradiated medium. That means that you're going to have the bending of light. There's no way, because we can't control the exact particle, like we can't make sure that the gradient is mathematically, exact to what's in there. You know what I'm saying? Like we can't ensure that every particle at a distance from the bottom of the thing has the exact same density all the way across, like the density of particles in an area. We can't guarantee that because it's random motion. It's all happening. We can say statistically speaking, there's always going to be a higher density lower than above, and to explain that is gravity. If you didn't have gravity, you would have
I didn't even get to that. I wanted to start
system.
talking about gravity because he kept saying about there being a dome and stuff, but Mr. Sensible's video shows that a dome isn't necessary. There's a pressure gradient going up to 10 to the negative 2 torr at 35,000 feet, Like, it defeats the need for a dome. And I wanted to get onto that with him, but he ran away because I couldn't be nicer. Team, I'm so nasty. I'm such a horrible person.
Nah, man. These people are stupid, man. But hey, I do have Gleam's in the chat right now, and he refuses to answer this question. And I've asked him several times.
Oh, that's because he doesn't answer questions.
GPS wants. Gleam, GPS wants to debate you on my channel. Do you accept or no? All you got to do is type yes or no. I'll know that you mean it's for me. If you send a one word thing, because everything you say has fucking 50,000 goddamn words and means shit. But if you send that one word, say yes, then I'll set it up for you in GPS. If you send
and I
one
promise
word
to keep
says
my mouth
no,
shut.
and if you send one word that says no, yeah, we'll be unbiased moderators. We'll let you and GPS just have a conversation. Obviously, I'm the most smartest person of all time.
The most
and
smartest,
you easily handed me, as you say to everybody else. So GPS should be nothing to you. So why don't you go ahead and accept it, and let's make that happen.
He says, fear the triangle, why would I? Oh, someone's just deleted. Please don't delete Gleam's messages, guys. I don't know who did that. He says that PhD Tony said GR and NLR are not equal. I think he's chickening out. I'll poke him on Messenger for you and see what I can
GR and what?
NLR are not equal.
Oh, okay. NLR.
Yeah. I'll poke him on. Oh, Gleam. He says, Team Skeptic, no, he lies to me and admits he can fuck off.
So you're scared? Who do you want to debate, Gleam? Come on. I'll bring you back on my channel. I'll let you pick the opponent.
Gleam,
you can't pick another flat earther. That's the only fucking problem.
Gleam, Homo habilis discovering his opposable thumb says what? I enjoyed that debate, though, because
I do have
a
few people, Gleam, I do have a few people that have reached out to ask me. I've said I wanted to start taking a more moderated approach to having discussions. So I would like to be a moderator. You can come on and speak all that pseudoscience bullshit that you believe that's absolutely incorrect. You can come and do that to another person, and maybe they won't be able to handle it. I think they will, but maybe they won't. Maybe you'll have a chance at winning something in life other than the loser lottery.
You see how powerful this laser is, team?
I'm blinded.
It's so powerful that it actually comes with an arming key. I got it from China because you can't buy them in England because they're too powerful.
Can I tell you something? You don't shine that laser into your camera, bro.
Yeah.
Like, it doesn't bother me or anything. It's gonna fucking start killing pixels in your camera.
It's so powerful. I can shine it on houses like 4 or 5 rows behind me and like still see it quite well. And my cats go fucking crazy with it. I wish they were in here.
Yeah, it's Gleam running away.
Oh,
Gleam, don't run away,
He's just sent me a photo. He says, GPS, when you admit you just lied, I will show you the full link. And then GPS says, Gleam, yes, I have lied. Gleam, is that, you're scared then, or?
You're scared, yeah, that's what he's saying. He's scared. Gleam, you lied too. So you lied the other day on my stream multiple times. If I have to go back through and look at it, whether you knew you were lying or not, you were lying. So, I mean, we can always go back and look at the tape and roll that back and tell people how much of a liar you are. He's
sending me a bunch of screenshots. Like, Gleam, I don't care about the screenshots. I really don't. We just want you to debate someone so we can laugh at how stupid you are. I mean, not much to it, you know?
Scared of wasting his time. No, you're not scared of wasting your time, Gleam.
Says the guy in my chat right now.
A flat earther. Yeah, you're a flat earther. Your entire life is wasting your time. That's what your whole life is dedicated to. Okay? Think of everything you've done, all the accomplishments that you're proud of for yourself, multiply them by 10, and you could say, that's how I would have felt if I wasn't a dumbass flat earther.
All right, let me read some more of these super chats, and then we can get out of here for tonight. How are you feeling, team? By the way, you're sounding a bit better.
A little bit better every day now. Whatever I had is going away, but
it's acclimatizing to the human atmosphere. That's what it is.
Yeah, well, I've had 40+ years to do that, I think, unless that's been just memories implanted into my alien brain.
Yeah, you're like new. We only hatched you a few weeks ago. Like the Team Skeptic channel, we've just planted that wasn't here a few weeks ago.
Yeah, let's see if the alien thing works. Did it immediately work? Did I get it to work on the first time?
Yeah, but it doesn't sound like an alien.
Oh, well, that's because oh, hold on. What the hell, man?
You sound like you're
It should.
behind a radio or something.
Oh. Well, that's because I was on a spaceship. I didn't do the alien one.
Ah.
Let me go to the alien one. You can tell me if I really sound like I'm from Alpha Centauri. Where the fuck is the alien one at? Holy shit.
No life can live on Alpha Centauri. I mean,
There's alien.
Sorry, go ahead.
Oh, Proxima Centauri is too close to its host star. I don't think it even has an atmosphere. How would you live there?
I have to hear myself. Whoa! Let me turn that off, because that's not...
It's hard when you can hear yourself, isn't it?
Oh, yeah. Well, I'm going to the turn off part. Okay.
Now we're doing better. Okay, I'm sorry, I'm back.
That's all right. They're a lot of fun. We need to figure out some fun things to do with them, definitely.
I've been thinking about it. I've been trying to put together, like, I like the one that's, hold on, I like this one. Can you do this real quickly? Or are you able to do it pretty quick? Okay, go to cave. And then you turn on your sound effects. You turn on your background effects and your voice changer. And I'll leave on my voice changer. And then we can, oh, here it is right here. Cave. Okay, this is cave. See, I got to teach you how to set this up right, man, so you can just click a button and it starts working. But yeah, let me know when you have, and make sure I can hear it too. See, we could do a inside the mind of a flat earther. Hello.
There we go.
I can't hear you.
This is what it's like inside Nathan Thompson's head.
Fight over here. Over here. I think I found a brain cell fight. It's over here.
Is it dead? It's dead, isn't it?
No, it's just rat. It's just rat shit.
No, that is a flat earther's brain cell.
Oh, that's a... Well, then, yeah, I have two brain cells over here. Would you like to lick one of them while I lick the other and see if they taste like human brain cells?
I mean, no.
Let me see if there's anybody else in here. Flerfs, now get there! Are you there? I didn't hear him. He must be gone already.
I'm here. I'm Thanos.
Okay. That's hilarious. No,
I see my Infinity
I'll keep the background
I lost that. Some squirrel go run off of it.
Yeah, God, is that you?
Okay.
Yeah. So yeah, there's a lot of fun that can happen there. Whoa. Yeah. You're playing some, like, let's get ready to attack the fucking tribe music. Are you there? Fight. I can't hear you. Are you there? I cannot hear you. Fight. I can't hear you. I don't know if you're talking. One in the chat if you can hear FTFE. One in the chat if you can't. Yeah, I can hear you now.
Okay, can you hear me now?
Yeah.
Hey, YouTube vMix was just crashing.
There's a lot of fun. There's a lot of fun that we can have with that. It's just gonna take I gotta show you how to set it up, bro. I can't believe you don't have this already set up.
I don't have it onto my Stream Deck yet. I was concentrating on getting my soundboard ready first.
I don't have it on my Stream Deck. You're a moron. I gotta help you out.
You're a moron, fucking alien.
No, do this. Do this. Like, here. Hold on. I'm gonna help you out. All right, I'm gonna help you out. First off, stop being a jackass. Go ahead and download RTX Broadcast. Okay?
Right, okay.
Once you have RTX broadcast, it has RTX voice built into it. You're going to take your input, you're going to go into RTX voice, you're going to change, really you're going to go to RTX broadcast, just go to the voice part. You're going to change your input to your USB microphone. You're going to turn the noise suppression all the way up, as well as you're going to turn on noise suppression as well, okay? Then you're going to go into your voice mod settings, and you're going to go into voice mod, and you're going to tell voice mod to get the microphone from RTX voice. Okay, that's going to clean your audio up. The audio is going to go to voice mod. At voice mod, you're going to output voice mod to a channel in voice meter. Okay, this is your listen back channel. All right, you don't want to use that channel for your microphone. You want to use that channel to listen to. What you want to do then is turn the microphone, or then you want to go into vMix and pull in an audio input from the voice meter or from voice mod. Okay, so you're going to pull the voice mod in. So what you're going to do is it's going to process through RTX, then it's going to process through voice mod, then you're going to get it. And if you ever want to hear what your microphone sounds like, you turn on, go to voice meter and route the callback or the talkback channel to your headphones, and then you can hear what you sound like before you make an ass out of yourself.
Like I'm gonna be listening. I'm gonna be honest. I stopped listening a while ago.
It's all right. I do this shit all the time. I do it all. You want to hear how I have my shit routed? You're gonna fucking flip out, right? I got my microphone, right? My microphone has an XLR cable that goes to my Scarlett 2i2. The Scarlett 2i2 then sends, that's the preamp. The Scarlett 2i2 then sends the signal via USB to my computer. My computer then, I take that as an input signal. I input that to the RTX voice. That goes to voice mod. Voice mod then goes to a channel on my Go XLR so I can control it with a fader and a mute button. So where you're at is about 3 steps behind where I'm at. So that's easy, to get it to just work automatically where you can just go to voice mod and control everything from voice mod. It's easy. One thing though, when you use RTX voice, turn off the noise suppression in voice mod because it's already being done in RTX. It'll sound over, it'll start pulling out parts of your speech. Don't do that.
I'll take your word for it.
Technical Skeptic is always available.
I still haven't decided on my new microphone yet. As Emma's doing Emma Reads Reddit, she wants to have a look at ones, and we can't make our mind up.
Sure, SM78 or 7B. That's what you
mean. We're looking at the Shores, and I think we're probably going to go one of those. Anyway, super chat. J.L. Warren for $4.99. Sorry. I shouldn't do bongs on stream. How do you justify the rewriting of the Book of Mormon to remove all references to Smith's polygamy? You're going to have to ask him these in a debate. I'll get you his contact. J.L. Warren for $4.99. How do you justify a rejection of gambling when you gamble each day with the choices you make? School, job, relationships. Oh, J.L. Warren going hard for the anti-theist debate. Let's get some Nathan Thompson memes up because they're always fun. Nate, play silly games. Win silly prizes. Craving Shaving for $5 says, very long time watcher, first time super chatter, but when you find out a friend from high school is a flat earther. Well, thank you very much for super chatting, and I'm very sorry about your friend. Syed Ahmed for $4.99 says, the modified professor. Hi, dummy. I'll pass his message on for you. Now, I'm not even going to attempt to say your name because I'm going to wreck it. I'm just going to call you Prez. Okay, you know who you are. And you gave me 25 PlayStation Network dollars. Greetings from Poland, FTFE, love your streams. Keep up fighting the stupidity. As stupidity is not a law. No, it's not a right, definitely. Thank you very much. J.L. Warren for $9.99. Seismic wave propagation absolutely proves a spherical model and we can make predictions with it that come true. Explain why those predictions don't come true on a flat earth. Mine Duck for $3 says, you can just say you're a professor now? Apparently he says he's a professor because he professes things.
Isn't that what a professor does, though?
No, not really.
No, a professor professes. I promise.
Yeah, I think his knowledge of the word professor is as good as his knowledge of the word pseudo-force. J.L. Warren for $1.99 says, because the atmosphere is full of sugar. Yeah, it's certainly not that thick. Excuse me. Okay.
Wow, I just realized I have a pretty fucking badass little black thing going on, like with my old black background where I had the like talking head look. I kind of want to turn on my camera right now to show everybody. You can finish choking while I do that.
String of News 1 for $2, so now he's just plain lying. Brilliant. Isn't that what they all do, though? I'll put you up full screen.
Oh, you don't have to put me up full screen. Okay, I take it back. Oh, hold on. There. Oh, yeah, my bad. I was looking at the wrong thing. Okay, no, I remember what I was trying to do. I was seeing myself on your screen and I was freaking out. I was like,
okay.
Like, boom.
Oh, yeah, that's cool. Oh,
and
what
then
are
we
you
have,
changing?
and then look at this. See, now look, when we have like guests on.
Ah! That's far too many skeptics.
Exactly. You see, isn't that fucking cool? This is coming to FTFE's channel. This is coming to my channel. This is coming to the SOS channel. As well as I have another thing I'm designing right now for my little game show I want to do. So
nice.
Hey, Gleam, this is fuck you for 4 times. There you go. 4 of us.
Tommy Grunveld for 50 Nokias. Not heard any counters arguments. You're doing your research wrong. The answer to your questions are not on Flat Earth YouTube channels. Go outside. Robert Williams for $2 says Kyle might not know 35,000 meters is over 100,000 feet. He doesn't know anything. Alan Brooke for $2 Canadian says Kyle, please shave. Cinnamon Control for $5 says for Kyle, in the sugar water test the city appears higher. The bottom of the city is displaced upward more than the top, so it is squished. Yeah, he didn't understand that at all. David Veller for $5 says refraction. So the flat Earth, sun and moon should be stretched out near the horizon every single day and not ever squashed. Yeah, reality disagrees. What the?
What? Oh, you heard that? Oh my
Yeah.
God, I didn't realize you could hear that. I'm sorry.
I was like, what did I do? What did I press? The plot hole.
That was my transition. That transition is so fucking badass, though.
Yeah, the stinger transition is pretty cool. The plot hole for $5 says JM Jr. You've no evidence. FTFE chat is busting your globes because metric system is better than freedom units. TPH needs U-boats. So close to 1K. Go and subscribe to the plot hole if you're not already, because they're awesome. And they didn't pay me to say that, honestly. David Veller for $20. Thank you very much. Says, so sunrise, observed horizon curvature, stellar rotation. All just happened to give us 15 degrees per hour of a 24,000 circumference. Flat earther. Come on. Refraction doesn't explain that. Oh, man. B-Ball for Life for $5 says, Kyle, why haven't any of the flat earthers on Ranties heard of you? Did you go over there and ask? Because that's fucking funny. Oh my God, they're going to be claiming I paid another one, aren't they? That's their thing at the moment. I pay flat earthers. Or fake flat earthers. String of News 1 for $2 says, not just the river in Egypt, again. And Cinnamon Control for $2 says, curved surface, flat gradient, still analogous. Jessica G for $2, are we sure this isn't JM without his bandana? It definitely is JM Light. The plot hole for $2 says, Kyle says, I'm a modified sniper. He's a modified professor. Bitwise for $5 says, is this JM Truth's camera guy?
Modified finger paint drawer.
Yeah. Atnick65 for £2.99 says, Professor of Knowing Sweet FA. That's giving him too much credit. Stringer News 1 for $2 says, CGI, CGI. And Nathan Termpson for 25 Australian dollars says, love everything you do, FTFE. Always a blast listening in, whether it's informative or a dumpster fire. Keep up the great work. I love it as well. Thank you very much. Otakaji for $2 says, so wait, we're breathing glass? I know that would be an issue. Bitwise 79 for $5. I wonder if JM's dad had a business trip to Utah. Stringer News 1 for $5 says, Kyle, if you cite Operation Fishbowl, you must accept the facts that come with it. I know, right? The Operation Fishbowl, that thing was at 35,000 feet. There's no evidence of that. What? David Veller for $10 says, Kyle, the sun, even on flat Earth, still many miles above you, so your example doesn't work. You argue as if it's near the surface, over and over. Yeah, he didn't understand my argument to that either. Chris Hoffman for $5. Kyle, your ad hoc attempts to lie have been done by many other liars before you. What makes you think your Poe attempts are different from the others? He's not a Poe. He's 100% not a Poe. He's just a fucking idiot. Team, did you just beat me?
Yeah, I want to tell, did I just, oh, you know what? I'm sorry. Got to fix that too. Yeah, so I inadvertently, right? So when I was setting up my voice mod, I wanted to set this one up so I could be like, hey, yo, Gleam, you know, I could do that right there.
Yeah.
But what I did is I inadvertently set it to my numerical pad enter key, which also happens to be like when I'm typing in a chat and I'm like, hey, fuck off. Beep. Oh, you want to know what 6 times 5 is? Okay, let me put it in my calculator. 30. Beep. You know? So I'll change that, but it'll eventually get fixed.
Guys, probably stop asking Gleam to debate. He's too scared. Plus, he knows absolutely zero. I mean, he doesn't even know what the Michelson-Morley experiment was. That's the best thing. I'm going to always poke you about that, Gleam. You don't know what the Michelson-Morley experiment was. You go on about it all the time. You don't know what it was. Therefore,
Okay.
you're unqualified
Gleam,
to talk about it.
Gleam, come back and let's talk about that again. Just me and you. We don't bring Fight. Fight can moderate, but just me and you. I don't need anybody else from the chat. I want to come back and really hammer into your head why you're getting what you're getting wrong. Because I agree with you on certain things. Like, there's just certain aspects of the Michelson-Morley experiment that need to be explained. You know, there does. It absolutely does. Many physicists tried to explain it given a faulty paradigm. Once the paradigm shifted, there was no need for any ad hoc explanation. It was just a consequence of motion with no ether. Okay? So, I would like you to come back on and have that talk with me, and we'll have an interesting conversation about that. Please don't time him out. Let him know that, or give him time to at least answer that question. But honestly, Gleam, you're not, you know, it doesn't make you right. You're not right just because you know how to say big words.
Or
you know how
cherry
to look
pick
up
things.
and yeah.
Like, Gleam disagrees with my conclusion that the Michelson-Morley experiment removed ether from science. All right, what they came up with, what they wrote in the paper was that
I knew you were scared of me, Gleam.
It appeared that the ether was stationary to the Earth. Yeah, but the result of all of that, Gleam, was that the ether was removed from science. Once a paradigm shift happened and they could explain the results, what the result of the Michelson-Morley experiment was that the ether was removed from science. No matter how many times you deny this fact, doesn't change it. I mean, I would agree with you, but then we'd both be wrong.
Yeah,
So
you brought up Lorentz. Lorentz understood that the Michelson-Morley experiment needed to be explained. That's why he said that there was length contraction going on. He didn't say anything about time dilation. He only talked about length contraction. And that there was a reason he only talked about that, because he needed to make sure that all observers, no matter what their emotion was, that they experienced light traveling away from them at 300 kilometers per second, 300,000 kilometers per second. So that's why he explained that. He didn't have anything to say about time dilation or anything like that regarding the Michelson-Morley experiment. And I'm sorry, Gleam, I know you think Einstein developed special relativity to destroy the ether and this and that, but that's not the case. Special relativity was concocted from Einstein independently of the Michelson-Morley experiment or any observation regarding light. Special relativity was simply a matter of trying to explain how Maxwell's equations would be consistent.
Thick. Sorry, he's like, Team Skeptic, stop pretending like you know what you're on about. You lied loads in our debate. You said general relativity and ether are not the same. No, they're not the fucking same, you absolute dipshit. General relativity removed ether. It's what
Dirac, okay, all right. Hold on. You have no Gleam. You don't know about Dirac or his equations, right? I showed you in the thing. You don't know about that. You can't tell me why. Tell me why right now. I'm going to ask you one question. I want the answer. It's a simple answer. Why did Dirac postulate that there were? I want to ask the question so it's easy for you to answer. Okay. Why did he come up with the Dirac sea? I'll just put it to you like that. Why did he come up with the Dirac sea? And I'll wait for your answer because this is gonna be funny. One simple answer, Gleam. Don't look up the answer. You should know this. Just type it in and hit enter. It's that fucking simple.
He's like, you're chatting shite with Einstein himself. Said Aether lives on. Oh my, Gleam, the king of cherry pickers. And Plip, who the fuck are you, Plip? You want to debate? Be a big man and step up. Otherwise, shut your mouth. Right. Syed Ahmed for $4.99 says the Flat Earth Institute has the same credibility as Trump's university. Michael Kenny became a new member. Thank you very much. You joined the Destroyers. That is awesome. You can now use the awesome emojis of Nathan Thompson in jail, dumpster fire. Thanks, Bob. Team Skeptic and a Mankini and the Vlad Blob. Johnny Marr.
Hey, just letting you know. I just letting you know. I'm letting all of my subscriptions, like my memberships, are all going to end this month and restart this month. So, in case you see me without it, I'm letting it all go away. It's because I'm changing credit cards, and I don't, like all this is on the old credit card. So I'm just letting them all close out, and then I'm gonna start them all back up. The ones that I want to keep at least, because I'm a member of certain channels that I just. Recently, I don't like what they have to say. So I'm just going to let it all end and restart it all back up. Just letting you know. Because I'm a member. I'm a member. I'm a real member.
I'm a real boy. Johnny Marr for £5 says, I love it when stupidity and exasperation makes you pat your head down and rub your eyes. I know. What's Plip saying? I've rinsed a lot of you before here in chat. No, you don't, Plip. You've never. No flat earther has ever rinsed me.
Okay. So, Gleam, you don't understand when he said the Higgs ether, he wasn't talking about the luminiferous ether, you fucking moron. See, that's why you don't know what the fuck you're talking about. The Higgs ether was simply the Higgs field. That's it. The Higgs field.
Yeah,
boom. There you go. So if the luminiferous ether is the electromagnetic field, like we say it is, that is the medium by which the wave propagates. If you would like to colloquially define a medium, it would be the electromagnetic field. Okay? So therefore, that comment that you just said, and believe me, you didn't answer what the fucking Dirac C was, that why he invented the Dirac C. And there's a reason why you won't answer that, Gleam, because you don't know the answer. Because you're entering into a realm of shit that you just read and go, that sounds like an idea that might support my idea. So I'm just going to start saying that. You don't know what the fuck it means. All right? Since you don't know what the fuck it means, you shouldn't be bringing it up, Gleam. You should just shut the fuck up and sit there and learn something for a change. And you still didn't answer why the fucking... Let's see.
He's like, why are you too scared to put up the MMX conclusion? Gleam, I just told you what the conclusion was.
Come back on my channel and I'll show you... Come back on my channel and I'll show you why you don't know what the fuck you're talking about. I'll even give you
too scared.
2 days.
He's far too scared.
Hey, you can come on tomorrow. I'll give you 24... I'll give you 24 fucking hours, Gleam, to come up with all the answers you need for any question that I'm going to ask. But I don't need I don't need to go and research all this. I know this shit. When you were asking the other day, it was like trying to explain why the kneecap of a unicorn is backwards from that of a horse. And you're like, what? The kneecap of a unicorn? How do I even answer? Oh, you don't know how to explain the kneecap of a unicorn being backwards from a horse? Well, then obviously you don't know fucking human biology. That's your way of logically putting shit together. And just because it takes me a second to go back and realize this is what he was fucking saying. Why didn't he just say it this way? First off, you don't know what the Dirac C is. You don't know how to explain it properly because I went back and listened to our debate. You are completely clueless. You see a solution to the Dirac equation that you saw that Dirac supported the ether. You saw a solution to the Dirac equation and you immediately put both of them together. That is incorrect. You can't do that because you don't understand what the Dirac C is. You don't understand why there's a Dirac equation. You don't understand any of this. You don't even understand what the relationship is between the Dirac equation and the positron.
Oh my god.
You don't know why.
Team, he's just messaged me on Facebook Messenger. You pussies need me silenced. Gleam, we're literally inviting you on to Team's show.
Yeah, come on tomorrow night. Quit being a scary little bitch. Quit being a keyboard warrior and put your money where your mouth is, bitch.
Gleam, I want you to listen very closely because I say this with all the sincerity I can muster. You're a fucking retard.
Retarded. Fucking complete. You're not even on the fucking scale, bro. You're off the fucking scale. That's where you're at.
Gleam, stop messaging me and just come on the team's show. Stop being a little bitch. Robert Williams for $5 says, put your hand a few inches over a boiling pot. The steam is hotter than the liquid water could ever be. Dunk your hand into the water. Which hurts more? Yeah, I was going to go over transfer of energy, but he ran away. Justin Nuav for $2 says, Kyle is now K.A. Truth with modified art training. Yes, absolutely. Dark Steve 84 also became a member. Thank you very much. You can use all the awesome emojis. Stringer News 1 for $2 says, oh joy, conflating definitions again. David Veller for $5 says, Kyle, as a Christian, you should know how to admit when you're wrong. You come off as self-righteous, so what if you're nice about it? Gleam, I literally just explained what the final bit of it says. Everyone heard me. It's been shown many times. Come on the show, stop being a coward. Sparky NJ for $2 says...
You said stop being a coward. That's funny.
He can't do that, I know. Sparky NJ for $2 says, sorry FTFE, couldn't make it an hour. Oh, fuck. God's Auditor for $2 says, Kyle, I passed physics with a 1.7. The person. Kyle never passed any physics. David Vetter for $10 says, pseudo has more than one meaning, Kyle. Here it is referencing as a consequence of another. Same motion each time this experiment is tried. If not rotation, then what causes it? We see the pendulum moving. He's too thick. Stringer News 1 for $2. Goalposts passing Uranus. Robert Williams for $5 says, JM Truth, Flerf, a channel barely alive. Gentlemen, we can rebuild him. We have the derpnology. Slower, dumber, more arrogant. We have the bionic JM. Yeah, what if like JM and Kyle are just like clones, but you know the ones that were rejected?
Well, the other thing I keep going back to is like, Gleam, why do you even want to have this conversation about the ether, man? It doesn't prove that the Earth is not a globe, and it doesn't prove that the Earth is flat. It doesn't. None of that changes anything whatsoever.
He wants to seem smart.
Fucking
that's what it is.
Globe. Yeah, I know, but he's only exposing himself as the person that not knowing what he's talking about. That's all he's doing, is exposing himself as someone who just doesn't know what he's talking about. He wants to believe the ether. He looked back at scientists who believed in the ether. There's no credible scientists after probably 1950 that even is really being taken seriously about the ether. Every experiment they do, and they consistently do experiments to test this theory out, always shows the same thing. That the Einstein special relativity holds up. Same thing with general relativity. And no, general relativity is not the ether.
Oh my God. He sent me a bunch of quotes that kind of disprove him. Einstein stated in his 1938 book, The Evolution of Physics, this word ether has changed its meaning many times in the development of science. Its story, by no means finished, is continued by the relativity theory. Yes, the word ether, you fucking moron, not the luminiferous ether. Where are your brain cells? Did you lose them as a child? He says, tell Team Skeptic when you can answer the 3 questions below, I'll come on and accept your apology. You ain't getting no apology because you're dumb as fuck, Gleam.
You're not getting an apology. What is his 3 questions? Let's just entertain me with them right now, please.
Well, it's the one that I just mentioned. Well, MMX removed ether from science. He says it's false. Well, no, that was literally what happened because of the MMX. You know, thanks to the results of the MMX, ether was removed from science. End of story.
So here's the thing, okay? If the ether exists, then there is a preferred frame of reference, okay? There's a preferred frame of reference for light to travel through. This would mean that light always travels at a speed through the ether, all right? Meaning your speed through the ether means nothing, right? Once you release light travels through the ether at a certain rate. So if you're going in the direction of the ether, you should be getting an ether drag. All right, this is I'm sorry that you don't feel this way, Gleam. I'm sorry you don't understand this. But if the ether exists, this is the prediction that should have been able to be made. When they tested the prediction, they did not see what they expected to see. Their null hypothesis was fucking confirmed. Now, getting rid of that faulty paradigm is what opened up everything else to what we have today. All right? Everything else that what we have as far as computers go, as far as our understanding of light, as far as optics, as far as everything, all depends now on the ether not existing. Now, Lorentz, hold on, before we go to the second part, now go ask the second question. That's the first part. That's why they removed the ether. It's not testable. Anything that you cannot test, it's just like removing God. Yes, science removed God from existence, really. One fucking gap at a time. Same thing with science doing the ether. Science has removed the ether from needing to exist for light to traverse the way they thought light traversed. We now know that light is not a wave, that it's actually a photon, an individual particle. Now go ahead. What's the second one?
2.
1921 Nobel Prize.
He says 2. GR is not mathematically equivalent to NLR. False.
General relativity is not equivalent to NLR. You know what? I would leave that to Clive Wells in the chat, who has a PhD in general relativity. So PhD, or I'm sorry, I was going to say PhD Clive. Clive, if you'd like to answer that question, please go ahead.
All right, and the third one is...
While he does that, read the third one.
Dirac did not have his own ether theory. He was just saying we deleted it without a thorough debunk. False.
No, Dirac believed in the ether. Dirac believed in something he could not explain. He also said that special relativity showed that there was no need for an ether. Now, he then said later in life that we took the ether out of science prematurely. Okay, that there is a rigorous method as to why you need to remove, if you're going to remove something, there's a rigorous scientific experimental method. The fact is, the Michelson-Morley experiment and all of the experiments afterwards, he didn't do this one time, Gleam. He didn't do this 2 times and give up. No, he spent 50 fucking years doing it, and every single time it didn't work. Okay? Dirac wanted to hold on to the belief too because he believed up until 1887, the acceptance of an ether was the basis of physics. There had to be an ether for light to travel. Why? Because they had already showed that light travels like a wave. So if it's a wave, it needs a medium. If it needs a medium, what is that medium? Well, it's the luminiferous ether. They just came up with it. It's nowhere. Gleam, you've never explained as to where the evidence is to support the ether. Einstein shows that Max Planck's quantization of light was actually true with the photoelectric effect. He proved that the 1919 Nobel Prize was given to someone who honestly truly deserved it by winning the Nobel Prize in 1921 based on the Nobel Prize in 1919. Okay? This was the beginning of an entire paradigm shift in physics, in science. We don't need an ether because light itself is not a fucking wave. You don't understand these concepts, Gleam. You don't need to be in a position to speak to me. All right, I'm done. Unless you want to learn, Gleam. You want to learn, come on with it. I'll teach you everything you need to know. Are you there, Fight?
Yeah, I'm sorry. I have myself fucking muted. My bad. Chris Hoffman for $5 says, Kyle, you just denied that people on roller coasters or in fast cars feel themselves pushed against the seat. This is why you are an idiot. David Veller for... Oh, fuck, it's just jumped. Sorry. David Veller...
Gleam, quit trying to be a fucking key. You know what? I'm done addressing Gleam in the chat because you're being a keyboard warrior now instead of speaking up like a man. If you got a fucking issue and you want to say something, fucking forums open tomorrow night. Show up and quit being a scary little bitch. Because right now, you're being a keyboard warrior, and keyboard warriors are scary little bitches.
Scary bitch.
Scary bitch.
David Veller for $5 says Bigfoot is not emergent consequence of cans falling or whatever the fuck you're talking about. Yeah, that was the dumbest argument ever, honestly. Excuse me. God's Auditor for $2 says he doesn't set the rules for words used here. No, he doesn't. I tried to be respectful of him and curb my language a little bit because I wanted the conversation to continue, but what a fucking idiot. Three Ron for $5 says, "Oh no, he cursed Kyle. Grow up, you pansy." Gleam says, "Absolute nutters. You have no clue what you." Yeah, right. Of course we don't. You fucking cherry picking
keyboard warrior. You
Yeah.
fucking keyboard warrior. Keep saying talking all that shit from behind a keyboard. That's about the only thing you're good at.
Truth Nerds for €5. Good job, Craig. Let me use my hands. Was my favorite part. Robeeb for $10 says he actually wants you to be more disrespectful, so he has a reason to disengage. Gleam, you don't know the first thing about science. Stop messaging me, you idiot.
So, okay, I in case that little jackass, the non-cursing jackass is out there, let me explain what the difference is in his example of how, the Bigfoot example, right? So let's say you believed Bigfoot existed, and you said, man, I've got, my trash cans keep getting knocked over every night, and there's huge footprints outside, just like Bigfoot said, just like it's explained, just like I believe, or I think to be true. So I'm going to test this theory out. Tomorrow, I'm going to put the camera at 5 foot in height because I believe Bigfoot to be at least greater than 5 feet tall. You put the camera out. The next day you come outside, you see your trash can has been completely demolished. It's gone through again. The footprints, new footprints, large ones, just like the night before are there. You go back, you check the footage. There is no break in the footage whatsoever. And there's no Bigfoot. This means that your prediction that a Bigfoot of something larger than 5 feet that could be captured on camera is false. It means you have to go back and come up with another explanation for your observations. Then you can test that explanation. You test the explanations until you have an explanation that seems to match every single time. Because if it's a 4'6" Bigfoot that happens to weigh 600 pounds and he's 4'6" tall and your camera didn't catch him, that doesn't mean he doesn't exist. It just means that you haven't refined your experiment enough to capture him. And then when you do capture him, then you can say, ooh, look, do I capture him every single time? I do. He must exist. And then until somebody comes forth with evidence to contradict your evidence, you can then agree to say, hey, it's a Bigfoot that's coming around getting in my trash. A 4'6" tall Bigfoot, 4'6" tall Bigfoot that keeps stealing all the trash out of my trash can. I have evidence to support that assertion. That's the difference.
Yeah, that whole argument was so fucking dumb. But yeah, Robeeb says he wants you to be more disrespectful so he has a reason to disengage without having to stick around and be disproved more. This is a low-tier evasion technique. How dare you? And then quit. Yeah, absolutely. God, my voice is going. I'm sorry. Robert Hirst for 20 sec says, isn't the Scottish term shite? Yeah, I mean, Scotland is just mostly swearing and haggis. That's pretty much what Scotland is. You don't need to come here. I've just told you. It's just swearing and haggis. Christopher Hoogan for $2 says your PayPal link is not fully filled out. I'm sorry about that. If you do feel like PayPaling me, then my PayPal is paypal.me/FTFE. Stringer News 1 for $2. JM Light abandoned us. Yeah, ran away. Mike Billers for $5 says intellectual dishonesty is much more disrespectful than a couple of 4-letter words. I didn't even start my 4-letter words. Don't. Justin Newell for $2 says his rage quit was so passive it was a beta quit. Stringer News 1 for $2. No, Kyle. PE is not physics. PhD Tony for $5 Australian says respect is not owed to people. You have to earn it. Kyle is significantly dumber than most cats. Yeah, I would say all cats, actually. Geza, the master reviewer for £4.99. Well done. Another one in the dumpster fire. Thank you. Made in CDA says $10 Canadian. For $10 Canadian, you have way more patience than most FTFE. This is for offending an idiot with simple words even he can understand. Thank you. P. Barnes for $5 Australian says, I hear his thesis was in why different coloured crayons don't taste the same. I think he likes the purple ones for breakfast. Mr. Unite for the children. $5. Here is his degree requirements from his Alma Masters Art Department page. Yeah, the requirements are basically you need to draw. Jessica G for $2. Gleam is really taking that loss hard. Yeah, I've closed down Messenger because he just wouldn't stop messaging me. You fucking beta mail.
Yeah, you know
Gleam.
what? You know what, Gleam? Here's what I'm gonna do for you, buddy. Till you agree to come back on and get your fucking intellectual shit pushed in, you can just fucking sit in timeout.
Yep.
Every single fucking time you open your fucking keyboard warrior fucking bitch ass mouth, you're gonna go into timeout until you agree to come onto my channel and get your intellectual shit pushed in.
Initiate the Vicky treatment, guys. Whatever happened to fucking Vicky? She stopped coming around, didn't she?
I don't even know that was a she. I think that was
no,
more like
it
Victoria,
was probably
British
a dude.
Columbia.
Yeah, it was British Columbia, Flat Earth, British Columbia or something. Victoria, British Columbia.
Oh yeah, Gleam. Don't forget, I believe Jessica G said she'd beat your ass up too. So yeah, I think wasn't it Gleam or was it Daniel Pratt maybe? I don't know. Either one
Daniel
of them can't
Pratt
handle fucking
said
Jessica G. So
Daniel Pratt said he'd fight me, and Jessica G said she'd stand in for me. So better charge
Jessica G. Unless you've lost your sense of smell, I don't agree. Don't suggest that.
Yeah, it's gonna be a knockout before you get in the ring just from the smell. Better charge for $5 New Zealand says, I will personally pay Gleam $50 if he goes on Team's channel tomorrow. Better charge, do not give your money to Gleam. Please.
Nah, fuck that, Belly. Nah, fuck that. Fuck that, Belly. We don't need it.
We appreciate the support to try and get him on the channel, but don't give Gleam your money.
Yeah, he'll just go waste that money on making bad music.
Yeah, because it's really not that good. Oh, anyway, Robib for $5. Gleam isn't a keyboard warrior. He's a keyboard monk because he's multiple stat dependent or mad. Yeah, he's just dumb as fuck, I think is the best one. And last super chat is from Craving Shaving for $2. The friend from school is Kyle. Not too surprised. Oh, God, you knew Kyle at school. Oh, I'm sorry, dude. That must have been depressing.
Yeah.
I want to say thank you.
Well, I'll tell you like this. Most flat earthers are very charismatic. I'm sure they were like that as kids too. They were probably the one that they were probably the kids that ruined the classroom for everybody with jokes, and the teacher was always having to say, hey, can you pay attention? Can you lift your head up? And instead of just acknowledging that he was doing something shitty, like not paying attention to the educator, they would make a joke to try to, make light of their bad actions. So I'm sure Kyle was like that growing up, and I'm sure as a fellow kid classmate, it was probably actually a decent thing to have him as a roommate. But at some point, people have to grow up and quit believing in fucking fantasy ideas. And unfortunately for Kyle, he hasn't reached that yet.
JM Light. Yeah, okay.
I actually like that, JM Light.
Yeah, so I want to say, honestly, thank you so much, guys, for the support, the super chats, and the members, and the PayPal donations. It's incredible. I love doing what I do, and I couldn't keep doing what I do without the support that you guys give me. The YouTube algorithm is a harsh mistress.
God, I'm sorry.
That's right.
I'm sorry about that.
The YouTube algorithm is a harsh mistress lately. YouTube is peaks and troughs, and it seems to be a bit of a trough at the moment. So to help get my stuff out there, and exactly the same for Team Skeptic, please share our stuff on social media. It is honestly, and I know I say this, but I genuinely mean it. It is the best way to help our channels grow, is to share our stuff out there. The more people we get seeing it on social media, the more it can get shared, and the more it will push us back into the algorithm. YouTube is peaks and troughs. I love doing what I'm doing. Yeah. The subs have slowed down a bit, but I mean, I'm sure they'll pick back up. I'm never going to just quit because, I'm having a bit of a slow month, but I love doing what I do for you guys. There was nearly 900 of you watching at one point today, and I couldn't ask for better. So thank you so much for all the help and support, honestly.
Yeah, and even me, when I bitch about it, people have to understand, I'm human like everybody else,
Yeah.
I'm going to have my moments where I
No, you're not human. Why are you fucking lying to me?
I'm pretty good at lying about my actual species. But even me, I get in these moments where I just get in funks. I haven't been feeling great lately, and a lot of that had to do, a lot of my worst attitudes have had to do with the fact that I've had a really shitty year, okay? And I'm not talking about financially at all, okay? Because there are people out there who are struggling worse than I am, and it's not fair to try to classify me in the same situation as them. So I don't even want to go there. I'm just saying, mentally, emotionally, physically, some of my health has taken a sharp decline for whatever reason. And it's nobody else's fault either. It's just something that I'm going through, you know, like it's all contributed to my bad attitude lately, and you know, I'm never gonna stop. This is the thing. I've always gotta. One day I'll find the perfect me. You know, the perfect me for YouTube. And sometimes it can be frustrating trying to find something, trying to find a style or a topic of discussion that's not just going to be friendly to YouTube's algorithm, but that I'm going to like to do, that my audience is going to like to watch. You know, I mean, there's like a whole bunch of different things that have to go into this, to being happy on YouTube, to being happy doing what we're doing. It's not just about the money. A lot of it, you know, like I do not want to put out a video and have only 5,000 people see it. That's not like what I'm here for. I want tens of millions of people to see my video, and if, you know, the peaks and troughs are working against that happening, it can be a bit frustrating.
Yeah.
So forgive me, anybody out there, if I was being a bit of a harsh dickhead lately. It's nobody's fault.
It's right. We're used to dealing with your team.
Things will change. Things will work out in the long run. I'm not going anywhere.
Thing is, our channels are still growing. Yeah, it slowed down a bit from what it was a couple of months ago, but like I said, YouTube is peaks and troughs, and it will pick back up again. And you know, it would be nice if more people were seeing the videos we put out. But you know, once we pick back up, then more of those get seen again. And you know, I just love doing it, and it allows me to support myself better than I've ever done before, and I can never be, you know, I could never explain how grateful I am for the support that you guys give me. Like I said, guys, please share my stuff on Facebook. If you want to join the channel, it's down next to the subscribe button, or you can head over to my Patreon, or even buy a shirt. I'm showcasing this one, which you can get for $18. All helps the channel grow. Tomorrow night, we're going to be on Team Skeptic's channel. Gleam's probably not going to turn up, so I think we're doing a game show, aren't we?
Yeah, we'll do something tomorrow night. I'm trying to get these game show graphics ready for tomorrow night. I don't know how I want to do it, though, because I don't know if I want to do it topic-oriented or play a few videos and get, like, have people do, like, the you know, like the 4 contestants do the reactions and explanations, and I just do my very scientifical, mathematical, logistically, argumentably sound way of keeping score. I need to get that all down. I need to get the graphics in there. So hopefully I'll have all that done. But tomorrow night, I will tell you this. There's something special about tomorrow night that will happen. It's going to be, I know I'm going to tell you because I don't like people going, oh man, I thought it was going to be this much or this. Tomorrow night I plan on implementing something that it's going to be a dramatic super chat reading. Okay?
Yeah.
It would be amazing. I'm telling you guys now, this is going to be amazing. I'm going to be standing up, moving my camera around. You know those videos where you got those like motivational speakers telling you how great of a person you are? Well, I'm going to read out all the super chats at the end of the show, and it's going to be completely dramatic and one of those like motivational speaker type things with my own addition to it. I've practiced. I looked in the mirror and practiced. Well, I looked in my cracked mirror and practiced. But
yeah,
it's going to be good. It's going to be good. Yeah, I tried to.
NASA Black Site, send me a squirrel and I'll add that as an emoji. Thank you guys for watching. I've had a great fun tonight. Episode 50 of Flerfs Are Idiots is in production, and also the comeback of Flerfs Say What, so look out for those soon. In the meantime, remember, stupidity is not a right.
Hey, fight.
You just ruined my outro.
I'm sorry.
You fucking ruined my outro.
I know. I have to fail for everybody. I just realized something. Tomorrow night's election night, so I doubt I'll be doing a live stream on my channel. I'll probably wait until Wednesday night, and that way we can talk about the world burning. We could talk about the world burning and the presidential election or whatever. But no, yeah. So tomorrow night we probably won't have a. I'll probably do a streaming. Stream. I don't know that you're still streaming, to be honest.
I think it's just buffering. I'll do the outro anyway. Remember, guys, stupidity is not a right. Fight the flat Earth. Fight the flat.
Fight the flat. Yeah, it just came back.
Fight the flat. 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 Fight the flat.